have a nice forum in this technology day. Thank you very much. Good morning.
Thank you very much, Pak Daru, for your warm welcome. Ladies and gentlemen, now I would like to introduce our moderator for the first session, which is AI and machine learning, Bapak Raymond Rasfuldi. So Bapak Raymond is the CEO of ZebraX, an organization that focuses on assisting company for the digital transformation. And he graduated from Texas A&M University, and of course he has a lot of experience behind him. And also we are happy that he is the head of digital transformation for Iafmi. So with that, I would hand it over to Pak Raymond to start the first panel discussion.
Okay. Hello everybody. Good morning. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Thank you very much, Pak Daru, for the welcoming speech, our Secretary General of Iafmi. And thank you very much, Bu Desi, our Executive Director of Iafmi. I mean, to open this this exciting technology day for us. I mean, at the moment, we actually roughly have 70 participants, and we actually have more than 120 registering. I mean, as of that was basically yesterday morning, so we look forward to actually have more people coming in as we warm up. First of all, thank you for all the participants and distinguished speakers of this Iafmi Technology Day webinar. I mean, to share and discuss the application of artificial intelligence and digital twin in the upstream oil and gas. We have heard about those two terms for the longest time, I think for the last 2 years. But haven't really seen a lot of adoption, as you can see. I mean, basically, at least in Indonesia at the moment. So it is very exciting for us to actually be able to actually have experts here today. I mean, to share with us. I mean, not only the technology but their implementation and application in oil and gas. Again, further to Ibu Desi introduction, allow me to introduce myself. My name is Raymond Rasfuldi. I'll be the moderator for the first session of the webinar here. We will have an opportunity to hear from 3 distinguished speakers. I mean, Pak Fajar, Pak Philippe, Herve, I'm sorry, Philippe, I mean, please correct me, and Pak Anil, Singh, I mean, basically from SparkBeyond, who will share their knowledge and experience in artificial intelligence, advanced analytics, and machine learning, and also its specific application and impact in upstream oil and gas. Before introduction of the speakers one by one in their presentation, I would like to inform all participants that to improve the engagement during the presentation, and also to allow our speaker to understand our audience better, there will be polling questions that we would like all participants to participate, and which the result will be shared immediately after the polling. I think that will be a good method to actually engage our audience, also help our speaker to understand basically our audience. We will also have a Q&A session after the panel discussion, and participants can type their question via the chat function in your screen portal. I would like to urge you to go ahead and type your question basically as the presentation is going on, and in asking your question, please do not forget to state your name, your company as applicable, and also the relevant speaker that you want to address the question to. And also please help us submit only the question related to the topic, so we can be very focused in basically answering them also. Okay, let's start with our first speaker. I think if we can go to the next slide. Okay, our first speaker is actually Pak or Mas Fajar Jaman, who is the founder and CEO of Iykra, a technology company that is focused on developing professionals and organizational capability in business, data, and technology. Mr. Fajar is very active in, and I'll see one of the key figures in Indonesia data science and analytics. Mr. Fajar is the founder of Data Science Indonesia, serves as the committee member in focus groups under the Indonesia defense industry, and also AI Center of Innovation under BPPT, or the Indonesia Agency of Assessment and Application of Technology. Mr. Fajar is a graduate from University of Padjadjaran, Bandung, and also a holder of a Lean Six Sigma Build certificate. Mr. Fajar will share with us why data and analytics or AI is important in today's transformation or digital transformation, and also introduction to machine learning and its application. Mas Fajar, because this is a digital session, the screen is yours. Please proceed with sharing the screen and start the presentation. Thank you.
Okay, thank you, Pak Raymond. I will start share my presentation immediately. Is it clear, the share screen?
Yes, I think it's clear. Thank you.
Okay, good morning, everyone. It's happy to be here. Thank you for Iafmi inviting me in this great event for sure. Meet with all the experts in oil and gas industry, and I believe we will learn each other from this session. So I will sharing about analytics for transformation. Then I will share about introduction on data science, machine learning, and including some essential things in data engineering. Yeah, so we will cover the essential things on the analytics itself. So back again, my name is Fajar Jaman, CEO of Iykra, and I have been introduced by Pak Raymond, yeah, advisor and founder Data Science Indonesia, one of the largest, perhaps the largest data community in Southeast Asia. I'm also community member in Ministry of Defense and BPPT. So my previous experience in market research, in consulting, in IDC, in Nielsen, and also I worked previously in Teradata, is a US big data company, is founded in 1980 in Caltech University, and had some experience also in oil and gas back then. So we start with story, yeah, since I only get 25 minutes, yeah, Pak Raymond, yeah. So I want to start with story about one of the famous airline company, Qantas, is on the major market share in Australia, 70%, and they have a lot of frequent flyer point in Australia. So they propose an idea that the frequent flyer can be converted and redeemed in some merchant in Australia. So the merchant like Starbucks, Subway, and other famous merchant is capable to redeem the frequent flyer. In return, the Qantas itself, yeah, can acquire the data of transaction. They can acquire the insight from the market, and they repack the insight into a business. Yeah, they have entity called Red Planet back then, and it's turning into airline biggest money spinner. So previously in before pandemic, perhaps, yeah, because we know the travel industry have impact on pandemic. Before the pandemic itself, the Qantas frequent flyer is bigger than airline business of Qantas. So the transformation is coming from the business hypothesis, turning data into a business value. So the story is to open the introduction about there is a real value in data itself if we can transform it correctly, right? So what is happening in data lately? I perhaps give a story how the data born in regularly. So not talking in specific on oil and gas, but in general, we know the data is coming mostly from transaction or interaction between the entity and entity. Let's say we have a registration some document in government, but nowadays the new data born, yeah, we are more interesting or looking for more on the interaction data. So not only the sales marketing data, but interaction data. And I think now it's happening. Yeah. But and perhaps some of the company in global, yeah, the big four tech company, global Google, Facebook, and Apple, now utilizing more on the interaction data, our digital mobility, our digital behavior. So this is real value of the data itself, not only on the transaction value, but the interaction value of data. And perhaps it's happening also in some um, car industry. Yeah, we know some some car like Tesla and other electronic car is try to learning from our interaction while we drive. So soon they perhaps build a model for selfless driving. So this is transaction interaction, one of the most popular data point that are become value in the future. And the question is how to connecting the dot, yeah, between the data itself and the business. Yeah, I perhaps take another example in digital. Yeah? I call it one of the largest data company in the globe. Yeah, people know they're using it now in social media, and they collect a lot of things. Yeah, the interaction data. So I want to introduce you about what's happening in general, and we will gradually take the alignment here in oil and gas. Yeah. So TikTok, Uber, Airbnb, Facebook, they collecting not the only transaction, but in convert the transaction interaction data into their model, into the recommendation engine, and it become a value for them. Yeah. So that's why their valuation is very high. Yeah, because they have the IP, the model that they built from the data itself. Yeah. So when it's happening, actually, I want to learning from the history, yeah, 2005 and 2008 momentum, when there is a tech breakthrough technology born. It's called Hadoop, yeah, or previously we call it a big data, yeah, big data open source, yeah. So and at the same time, we also experience with a born of digital culture when Android smartphone release, yeah, with a very cheap price. So everyone using digital, but there is a big data nightmare here. It's spoiler alert, yeah. In big data world, we just realized. So after we realize there is big data, we just realize that data always limited, yeah, and we don't have data. We're always looking for how to collect data, how to collect data, and this is the thing that happening now also when we try to looking for alternative data available, yeah. We will try looking for the social media data, voice and text, call center, integrated web data, and also the sensor, yeah, the sensor that enabled in IoT sensor. So it's all actually the alternative data available. So this is the some sample of experience that I are usually working on digital company. Yeah, how to analyze the clickstream data. So we know the transaction is recorded by apps perhaps, eh? But the beauty of analytics, we want to look the overview of the customer. So that's why we collect the interaction data. When they click, when they move, when they search in within the application, we try to collect it. So it's not it's normal when we talk about big data, when we talk about the analytics, advanced analytics, AI machine learning, the data storage become bigger, and there is computing challenge, yeah, because there is a lot of data that you collect, yeah. Take example in one of the application as well. We usually looking for what kind of data do we have, yeah. Not only traditional data, but we collect the GPS, we collect the heat, we collect the interaction. And the question is, what kind of data do we have in oil and gas? Perhaps um, all of the participants here is coming from oil and gas and have more experience, have more knowledge, the context of the oil and gas. And it will help for us to utilize or mining the data in oil and gas as well. So move to data science practice. Yeah. So I back again my the history back then when we call it data decision support system. We also heard about management information system. We heard about also business intelligence or BI. No, it's data science. What really is data science? Basically, all of this technology is focusing on the data and analytics. It's matter of how the approach now is quite different. Yeah, we think data science is the process of cycle. Yeah, some of them call it research process. Some of them is a business process. But there is three field discipline that perhaps need to be acquired here is quantitative, a business, and also engineering. Yeah. So the process of the data science itself is an iterative process. Yeah. So Basically, it's coming from the input, the data itself. We process it in the storage, and we provide the output. Yeah, this is the regular cycle, and the quality of model, the quality of insight is really depend on the quality of data. So there is a lot of things to do when we call it data preparation. Yeah, we have to enabling it with the data collection part. I will share more on detail. And also the difference is now we're not thinking on descriptive analytics only, not analyze as it is, but we're thinking moving forward on the predictive and prescriptive, not only what happened but what will happen, or even how can we make it happen to optimize the business. Yeah, and there is at least three people nowadays, a lot of various of data role, but I want to put in simplified into three type role. Yeah, data scientist, data engineer, and analyst. Yeah, perhaps these three uniqueness is data scientist play major role on research, engineer on preparing the pipeline, engineering, data engineering, and also data analyst is more on business side. Yeah, so I want to give a more explanation on machine learning. And last week I just got the good recommended movie on Netflix. Yeah, we call Coded Bias. So it explain more on machine learning. So back then, how the normal machine works actually. You know, in normal program we define the rule and they will running into some protocol. Yeah, but on the other hand, like a human start walking, human born and start walking, and we expect the human also can run and become master. Yeah? And but it have to be through the consistent training. Can computer do the same? Yes, we call it machine learning. So the machine can learn. Actually, there is some approach on method, different supervised, unsupervised, guide or unguide. So we have a lot of technique here in machine learning, depend on data and the context and the use case. Yeah. Some supervised learning, to simplify, there is a power to classify which one is A, which one is B, yeah, or regression prediction to define the concrete number on some measurement. So how is it really works? Yeah, like a human, we need a training. We will prove the testing and we do evaluation whether the machine is learn enough or not. Yeah, by do the trend testing, we have a training data. So to make it the machine is smarter, we need to put it with the data. Yeah, then we testing it. It's some data split between the training and testing, and to checking the brain of the machine. Yeah, the smart of the machine is to checking with through all of the validation. Yeah, and nowadays we call it AI. Yeah, but there is some technical approach here. So data science, what is data engineering actually? There is some shifting from the traditional database. We call it SQL, relational database management system. There's limitation also in database traditional. So, but actually, when we have a transaction in application or any other scheme, we put it on the server. Yeah, we call it OLTP, transaction processing. We put it on the same server. We query reporting on the same server. But we move into analytic phase. We need to have enterprise level decision. We cannot depend on each department provide our report, but we need the enterprise level to have all the data in enterprise to be analyzed, store and analyze. So we call it a big data capabilities. So that's why the Hadoop component play major role here. So moving from OLTP, we now see the transformation a lot of enterprise in Indonesia to building all up our analytic environment. So there is split server environment between the transaction and also the analytic environment. So it's very significant because this how we can do a research. That's how we can do exploration on the data without interfere the production. So when I work in Teradata, we provide the enterprise data warehousing services. The architecture itself more or less like this, yeah, input process output. Yeah, We provide the data, we store and collect on the processes layer, and the output, we can call it data visualization, reporting, or any others output. And I want to show you what we really did in some real project. Perhaps it's quite similar with the oil and gas industry, yeah, because we play more on sensor. So in one of the project in Katingan Mentaya is the largest REDD plus project in Kalimantan, or perhaps in the globe. We provide the sensor, yeah, we provide the drone, yeah, to cover the area, because we want to prevent early warning system on fire on the forest, yeah. We put remote sensing IoT device. So basically it's same, yeah, input process output, yeah, regardless the type of data, yeah, whether it's coming from IoT, drone, or transaction data, it will be stored in analytic environment, and we will provide an intelligence for the user, and it will be cycle for this process. Yeah, some sample case that I can share is also in one of the our client in tobacco manufacture, is a predictive maintenance. We analyze the log of electronic, the log of the machine in their one of the machine in manufacture, to prevent to do a predictive maintenance. Yeah, so we will uh, prepare the machine spare part changes before it's broken. Yeah, so we analyze error data, maintenance data, and all the sensory data to prevent the failure. Any other interesting project, perhaps the prediction on COVID-19. We analyze not only the healthcare medical data, but the flight, yeah, the flight traffic, yeah, the traffic from outside Indonesia to Indonesia, and define the metrics, the prediction each island. Yeah, also in the one of the banking in Indonesia. And we also have event previously we call Circle of Data Leaders on oil and gas. We did some POC project for drilling optimization. So more interesting on oil and gas, perhaps we will talk on more on the operation, production, and there's a lot of interaction data that I talked previously, and it's a value, that we can convert. Yeah. Another project in German, we provide the computer vision to do a smart farming. So it's also sensoric data that really happening in Europe to improve the milk production. So thank you everyone for the attention. That's all for me, and I will give a session to Pak Raymond.
Thank you, Mas Fajar. And you are doing very good on time, Mas.
Really?
So you are doing very well on time. So don't worry.
Sorry
on time.
to
That was good.
speed up something, Pak Raymond. Yeah, I will.
Well, no, actually, you actually have a little bit more time. So if there's anything you want to add specifically, I mean, there is some time, or you can go ahead.
Yeah. Want to understand previously that the profile of the participant, yeah, because
Right.
whether you are coming from statistic background, whether coming from business or engineering background, we all have a role in analytics. So the data is not the role only for the statistic or computer scientist, but everyone. So that's
Okay.
what we try to encourage everyone to join into the discussion, especially when we talking on the specific area like oil and gas. Yeah, we really
Yeah.
need people like Pak Raymond, yeah, Pak Daru, yeah, who understand the oil and gas very well, to help the data team, let's say, or data process, guide the process into a value. Yeah, because the creativity is coming from the context of the subject matter expert.
Okay.
Thank you.
Thank you for that last bit. I think that put it into context, Mas Fajar, in terms of oil and gas. Also,
Yep.
that was a very good sharing from Mas Fajar, related to basically the importance of data and how to extract value from data. I think that's very important. That's the reason why I think we all here is try to actually get the value or the impact of the data that we have. And I saw basically some general application. I mean, of machine learning to business, but there is also some specific application. I mean, to predictive maintenance that's mentioned there. I mean, drilling, which is very applicable to the oil and gas industry. But also, I think, I mean, a lot of I think the audience here, especially Iafmi members, who are actually, I guess it is an expert organization in oil and gas, so there is a lot of engineers, Mas. So a lot of engineers, I think some of us can relate to some of the presentation that Mas Fajar had in terms of regression. We actually have gone through mathematical modeling, right? I mean, and we can discuss that later about what is the difference between the mathematical modeling that we had before and the data science and analytics. We can discuss that during the panel discussion later. Mas Fajar.
Thank you, Pak Raymond.
Thank you very much, Mas Fajar. I think that's a very good introduction to kick us off. I mean, to our next presentation. Again, in terms of participants, we are close to hitting 100, right? So it's always warm up a little bit. I mean, as we move along during the day. Next, allow me to introduce our second speaker. Basically, is Pak or Mr. Philippe Herve. I'm sorry, Philippe, please correct me. I mean, if I just butchered that name, sorry about that. Who is the Vice President of Energy with SparkCognition, a technology company that aims to catalyze sustainable growth throughout the world with proven artificial intelligence system, award-winning machine learning technology, and a multinational team of AI thought leaders. Mr. Philippe has comprehensive experience in oil and gas that spans from large-scale project leadership, IT, engineering, manufacturing, and operations. Mr. Philippe holds multiple patents in the field of ultrasonics and has authored many technical papers. Philippe holds a Master of Science from the Institut National de Sciences of Appliquées in Rennes, France. In today's event, Pak Philippe will discuss about artificial intelligence value across large-scale application, where he will also share specific application of AI in upstream oil and gas. Pak Philippe, I mean, the screen is yours. Please start sharing your screen, sir. Thank you.
Thank you very much, Raymond, for this introduction. And it's a pleasure to be here today with you. I really want to thank IFMI for giving the opportunity to speak with this distinguished crowd and move forward. So let's move to the next. Yep, perfect. So today we're going to speak about artificial intelligence value across large-scale application. And there is a poll on your screen right now which is asking you a question on what do you think subject matter experts should be doing on how much should they know about data science and artificial intelligence. So should the SME run their own data science using Python? Should they give the data science project to the data science team to provide a completed project? Or should they run their own data science using zero-code platform where you really don't need to know anything about software or anything about data science in detail? You understand what is the software, you understand what data science is, but can you run those projects today using zero-code?
Okay, let's wait for a couple of, okay, there you go. We start getting results.
Yeah, no, we're getting some good results, and I think we can stop the poll here and share the result. We have enough information to see that really this group here believes that the best thing to do is to provide the project of data science to the data science team and wait for the result. And let's stop sharing the result. One of the problems that we do if trying to get, okay, is that historically there's been a mathematician shortage. You know, if you look at back in the 50s when artificial intelligence was invented by Alan Turing, also the name was only coined a few years later by Mr. McCarthy. But really there was a shortage of mathematicians. And to the point that the mathematicians were actually called human computers. This was the name back then. And what happened in the 60s is the human computers were replaced by what we know today as being a computer. This is when the computers were invented and introduced at scales. They were big, they were massive computers. They couldn't do half of what the mathematician could do, but they could do it faster and reproducibly without making error. What happened to the mathematician at that point of time? They went back to academia. They went back to R&D and they created the next thing of technology, the next area of technologies, which was better software, better hardware, better cars. A lot of new things has been happening. But if we keep on the current trend, you know, we had in the early 2000s, late 80s, 90s, and 2000, there was a huge shortage of software developers. We couldn't find enough software developers, which are just very good mathematicians with a skill on software. But what happened is we started to develop a lot of visual tools to develop software, Visual Basic, Visual C++, and many, many more, where you could develop software without really knowing too much about the underlying code, or at least you could do it better, faster, quicker, more reliably. And what happened to those software developers? They went back to academia and to R&D. The world still needs software developer at scale, but this massive demand for software developers, which was predicted in the 80s, never had to happen because of the automation of technology. And what's happening today in, you know, we have a huge shortage worldwide of data scientists. There is not enough data scientists to fill all of the demand for data scientists. But something is happening at the same time, is that we are moving into what's called zero code and automated model building. And with zero codes, we now are giving the power to subject matter experts, to engineers, to run their own data science without really knowing too much about data science. We all use computers. We don't really know too much about computer. We use Excel, we use PowerPoint, we use MATLAB, we use CAD tools. We understand what they do. How do they do it is not really important. You know you have a problem, you know that tool can solve it, and so you use that tool. And as a subject matter expert, trying to be the best you can be in reservoir engineering, in mechanical engineering, in drilling engineering, now you are able to use modern tools to run your own data science without knowing Python, without knowing deeply how data science works. You just understand the concept, you know you have a problem, you want to get a solution, you apply AI to your problem, and you get it done. And this application of zero code and automated model building is what is enabling today the rapid development of very large-scale projects, because we don't need tens or hundreds of data scientists to develop projects. We can develop very large-scale projects quickly and efficiently using tools. What's happening to the data scientists? They are going back to academia. They are going back to research and development. And I'm very excited about what is the next thing they are going to invent for us, which is going to be another revolution. But this massive demand for data scientists, which was predicted 10 years ago, is not needed anymore because we have tools to do the data science automatically. So let's switch topic a little bit and say, okay, we're going to do artificial intelligence, and we're going to use a lot of data to do artificial intelligence. The first thing that you must do, that is mandatory, is take care of cybersecurity. And the good news is modern cybersecurity tools are AI-based. Today, one of the biggest challenges that you have with cybersecurity, cyber attacks, with the hackers, is the amount of malware that they produce on a daily basis. There is about 1 million new malware per day. 1 million new malware. Now, the traditional way to combat those malware with endpoint cybersecurity is to capture what those malwares are somewhere in the world using what's called honeypot, extract the signature and push the signature to all the endpoints, your computer, my computer, the servers around the world. This was possible when there was a malware every quarter. With 1 million new malware per day, the paradigm is broken. And this is where artificial intelligence-based cybersecurity and endpoint protection makes a lot of sense, because now you install an agent on your computer, and it is going to block all the traditional malware, which are well known, but also the brand new malware that have never been seen before. And you do not need to update your anti-malware on a daily basis. Very, very important tool. And if you look at, multiple traditional anti-malware and their reaction against the leading AI-based anti-malware, Deep Armor in this case, Deep Armor blocks 99.8% of the new malware, never seen before. Traditional technology blocks anywhere between 60 or even less. I just took some of the big name here, up to maybe 85% of the new malware. This is for brand new malware, never been before. On traditional malware where daily update works, everybody's at 100%. The risk is coming from those brand new malware, which are eating us every day. You get 1 million new malware coming to you. If you have not been attacked today, you will be soon. I was speaking with the Chief Information Security Officer at a conference recently. Not recently, it was about 2 years ago, a year ago. And trying to speak with him about, putting AI-based anti-malware to his infrastructure. And he told me, no, we know what we're doing. We are very well protected. We use all kinds of layers in our cyber security tools. There is no way we get attacked. About 3 weeks after I spoke with him, that company got attacked, and it cost them $300 million. $300 million. It's very well advertised. You can do some research on find who they are. But they are not the only one. It's just one of them that happened to have been speaking with the CISO a few weeks before. And it happens on a very, very, very regular basis. So now, let's assume that you have protected your system. Let's look at how you can use artificial intelligence at scale. This is a project which is currently believed to be the largest implementation of artificial intelligence in oil and gas. By the way, at SparkCognition, we do many, many, many different markets. We are working in aerospace. We have the largest AI-based project in aerospace with Boeing. We work in many other industries, but today I'm going to focus in oil and gas. This project for BP here, we are doing predictive maintenance on their offshore production platform, their refineries, and their petrochemical plants. Now, the petrochemical plants is a bit of a special story because that part of the business was sold to INEOS at the beginning of the year. So actually, our client now is INEOS for that particular set of products. But we still do the offshore production platform and the refineries for BP. The project started with this one platform here, which we see on the screen, called Atlantis. It took us about 2 months to deploy on 20 subsystems once the decision was taken to move forward. The objective was to predict upcoming failures at least 4 days in advance. We are at 9 days on average. And once we got at scale to all of the platform that we're currently on, the improvement per platform on average is probably about 1%. So we are improving production for BP of about 1%. Now, 1% may not sound like a big number, but when you have 30 platforms doing 200,000 barrels per day, I'll let you do the calculation, but it's very close to $1 billion of added production on an annual basis. Very, very significant improvement. In one particular case, on a platform which was already very efficient, we were able to raise production by 4%. This project was selected at ADIPEC for the ADIPEC Awards in the Digital Transformation of the Year category and was a finalist in 2020, the last edition of the ADIPEC Award. And at the ADIPEC Award, there was about 600 projects presented in this category and only 3 finalists, and we were one of them. So very, very proud to have been selected with this project and recognized by the industry as a very, very significant project. One of the things that made this project very successful is that we are speaking about predictive maintenance. So yes, when we got started, we started to predict this compressor is going to fail, this pump is going to fail, this heat exchanger or this glycol system is going to fail. And we got very good, very, very good results. But what was really the key point in making that project successful was when we realized that we could detect process anomalies, sorry. And those process failures are actually generating 3/4 of the production impacting events. Yes, of production impacting events, which is when you lose some production, only 1/4 are generated by a system, an asset failing. Something needs to be repaired. But 3/4 of the production impacting events do not require any particular maintenance. The system needs to be shut down and restarted safely in a controlled manner. By being able to predict those upcoming process failures, being able to have a very significant impact on the production. And this is what was really a key factor in being able to expand the project so quickly on so many assets. The second project I'd like to speak to you about is something which is at the other scale, at the other end of the scale. We just looked at very, very large offshore production platform, 200,000 barrels per day. Here we're going to the North Sea. It's an unmanned platform for Iykra BP. It's called Tambar. There is nobody on this satellite platform. There's about 6 wells coming to the satellite. And the total production is maybe about 8,000 barrels per day. The problem we have here is those 6 wells, sorry, the production is pushed to a nearby facility called Ula by this multi-phase pump, which we see on the screen. This multi-phase pump is really the asset that fails. And the challenge here is that when it fails, it takes 3 days to bring people and equipment to the platform. Best case scenario, 3 days. The challenge in the North Sea is weather, bad weather. And so before you can send people or equipment, you actually have to wait 1 week, 2 weeks, 3 weeks, maybe more, until you get a weather windows that allows you to go and do the maintenance on this pump. As a result, this particular platform is the worst producing platform for Iykra BP and for many operators around the world, but that's why Iykra BP asked us to look at it. This platform was in the low 60% availability after we implemented predictive maintenance on this particular pump on the platform in general. We raised it to 99% plus. So we have been able to predict the upcoming failure. When we got started, we estimated on historical data, we'd be able to predict about 75% of the failure 9 to 12 days in advance. Something that was spoken about in the previous presentation is machine learning, how the computer keep on learning. As we move forward with this project, we are now able, we've been able to detect every single upcoming failure in the last year and up to 25 days in advance. As the system keeps on getting data, it keeps on learning, getting better. And this significant improvement was actually spoken about at ADIPEC again in 2019 And so 2 years ago, this project was also selected by ADIPEC for the ADIPEC award ceremony in the digital transformation project of the category. And once again, there was about 600 projects presented, only 3 projects in the final. So very, very proud to have been selected twice in a row by ADIPEC for such a significant award. So what we looked at here was implementation of predictive maintenance on large platform, implementation of predictive maintenance on small platform. We also do FPSOs in the middle. To us, if you have pumps, compressor, generator, glycol system, processing units, or processors in general, the physical factor of those assets doesn't really matter. Whether it's a production platform on FPSO or on an unmanned satellite platform, to us, it's data. And the way we make sense of this data is by working very closely with your team, because nobody knows your asset better than your subject matter experts, and nobody knows your data better than your data scientists. So we work in teams to make sure that the work we do is very oriented towards solving the problem you're having. We just look at offshore, and yes, we do a lot of work offshore, but really, we also do quite a bit of work on land in gas processing facilities, in refineries, LNG trains on terminals, petrochemical plants. Once again, to us, data is data is data. The physical factor in which this data is being generated is fairly much independent to us, whether it's floating or it's on land. A pump is a pump is a pump. And what we look at is that all the data you are receiving, and we analyze this data. And that brings me to a very important point, is which data do we need to get started? We need the data you have. Let's get started with the data you have and see how far we can go with the data you have. Maybe you have 10 questions, and with the data you have, which is essentially free, you already have it. Maybe we can only solve 7 questions, but hey, we solved 7 questions out of 10. For the last 3 questions, let's have a business discussion. What would be the cost of solving those last 3 questions? How many more sensors are required? And then once we take this decision, does it make business sense? Artificial intelligence is used in many other places, whether it's for failure prediction on surface equipment, and we looked at quite a few examples. We also do that on drilling rigs. Whether it's to optimize the drilling operation, and I'm going to come to this, but we also look at failure prediction in the formation, reservoir engineering and tactics, predicting water conning, optimizing your seismic processing. AI is used in many places today in the oil and gas industry. And I would encourage you, if you are not yet started, to get started with AI. Let's look at a few use cases. This one is about drilling. And here in this particular case, we are predicting stuck pipe events and washout events. For the stuck pipe, for this particular client, which is on land in the US, predicting stuck pipe event about 1.2 hours in advance, and washout about 2 hours in advance. It's a risk indicator. We are predicting that you're going to get stuck if you keep on doing whatever you're doing right now. This is what predictive is, which is somewhat different to prescriptive. Prescriptive is we tell you what's going to happen, and we tell you what to do about it. In this particular case, it's for this client, he said, just tell us if we are going to get stuck, and we'll take care of it. So this is what we are predicting. We are predicting you are going to get stuck, and then they know what to do. They'll do a short trip, they're on a peel, whatever working for them in that field, that's what they do. We do predictive in this case. For other projects, we do prescriptive. We provide what the client is asking for. When I look at predictive analytics for drilling, this is actually some of the other use cases we work on with clients around the world, quite a bit in the Middle East actually. But not only stock pipe or BHA washout, also formation washout, loss circulation, pore pressure prediction is the project we run with Shell, stick slip, vibration, BHA worm. Let's remove all of the dysfunctions. And once you have removed the dysfunction, then we can start to look at optimization of the drilling, optimizing ROP. What data do we use? Once again, the data that you already have, your RPM, your void and beat, your flow rate, and other surface data. This is another use case used for artificial lift system, whether it's ESPs or jack pumps, predicting upcoming failure on the equipment itself, but also in the formation, and predicting what would be the return on investment, the production post-repair. If you predict that a well is going to fail, what is the repair? If it's surface equipment repair, that's easy. But if it's a downhole well failure, should you acidize, fracturate, reperforate? What is the cost of this operation? What is the predicted post-repair production of the well? And then you can classify all of your wells and organize them to define which one is the next well you should be working on. Very important. This is a project, one of the projects we do on ESP pumps, where we are able to predict on average for this particular project, I think about nine days in advance. Some of are more in advance, some of them are less in advance. It all depends on the data you have. We spoke previously about data quality. The type of data that you are able to provide on day one is what's going to predict the level of quality of the first few projects. As we move forward on progress with you on the data quality, on amount of questions to be answered, then we make business decisions. Should we get a better prediction on this particular challenge, or is it more important to go and work on another challenge? Then you can make business decisions because you already have some results and you know how to work with artificial intelligence. Now, very briefly, I'd like to conclude with a few slides on why do projects fail. If you look at change management, there is always 3 points: people, technology, and processes. And one of the reasons that in the change management system, the house fell is we try to change everything at once, try to change the way people are working, the processes, the technology all together. And when this happens, typically your project fails. Now, the people are the biggest barrier to change. So it's very difficult to ask your people to change if they don't see the value. And AI is frightening because thank you to the movie Hollywood making you think that AI is bad and dangerous, people are afraid of AI. The truth is we are nowhere near to what's presented in the movies, but that's a scary factor. So if you want to have your first successful project, concentrate on projects where only the technology gets changed and where people and processes are not affected, or as little as possible. And that's why I like so much cybersecurity and predictive maintenance. Because when you implement cybersecurity or predictive maintenance, you are not asking the people to change a lot on what they are doing, and you're not changing really a lot of the processes. If something is going to be failing, it still needs to be repaired. So your technician, instead of being the bad people that are always repairing when something is broken, they become the good people and they go and repair things before they break down. So their work has not changed, but the value of their work is very important. Now they're seen as the good people that always fix things before they break down. And so those people that you have made stars in your company are going to support you, to help you during the next project where changes in the people and the processes will be required. With this, I want to thank you very much for your time. And I think we will handle the question and discussion towards the end. Raymond, is that correct?
Yes, that's correct. I mean, we will go ahead and actually finish our presentation before we actually have a panel discussion and then a question and answer Philippe. Thank you very much, Philippe, for that very interesting and insightful, basically sharing. And I think you highlight a couple of things. First of all, I think what is interesting and important is the duality of implementation of machine learning. I mean, between the SMEs and the data science expertise, right, on how to do that. I think that's one of the things that's always interesting to talk about, right? I mean, how is that going to be working? The polling basically result is also interesting to me. I think that shows the understanding and probably a little bit of a expectation and the gap between what technology expected and what the SME expected. We can discuss that further during the panel discussion. That's very interesting. Cybersecurity. I mean, yes. I mean, recently you actually get more and more scared, right? I mean, there is so much cybersecurity breaches, either in personal context or even corporate context, that it becomes a very big concern and even a blocker for digital transformation. And basically key successes. Looking at the behavior of the system instead of the specific solution that you wanted to find. I think that's also key. And you mentioned something that we will discuss later that will be interesting between, you mentioned about prescriptive, predictive, and optimization, right? And what is that a journey? I mean, that's something that we would like to discuss further during the discussion panel, and then the pitfalls and how to approach the digital transformation. Thank you very much, Philippe. We will discuss later with all the other speakers. On those key subjects, which also echoing what Pak Fajar has mentioned earlier. Thank you, Philippe. And I think we actually have our next speaker here. Let me introduce Mr. Anil Singh, or Pak Anil Singh, who is the impact partner in Asia Pacific for SparkBeyond. SparkBeyond is a technology company that has built an AI-powered problem-solving platform that is capable of finding complex patterns in data and understanding their meaning, and harnesses the world's collective intelligence. I think data enrichment, right? I mean, to bring powerful insight and accurate models. As the impact manager, Pak Anil is SparkBeyond ambassador to the clients across the Asia Pacific region. And through the course of 12 years, Pak Anil has worked with prominent startup and large-scale operation, building scalable business, including leading teams in Microsoft and Lazada. I think we are familiar with Lazada. And with SparkBeyond, Pak Anil has helped state-owned enterprise in oil and gas in the Asian region, deploying advanced analytics for hydrocarbon value chain optimization and downstream expansion. Pak Anil holds a master in management degree from EDEC Business School in Nice, France, and a bachelor's of technology in electrical engineering from National Institute of Technology, Rourkela, India. Pak Anil will share with us SparkBeyond impact and transformation experience in oil and gas with its specific use cases. Pak Anil, the screen is yours.
Thank you, Pa Raymond, and thank you, Iafmi, for inviting me today to just share some of our experiences. Before I get started, I'll do a quick introduction about what SparkBeyond does. I'll touch base on two things. One is our experience in Upstream with the largest player in Scandinavia, and also some of the Asian experiences. But I'll also be happy to share experiences in Indonesia, where I've been fortunate enough that I've traveled extensively to Kalimantan, where I've worked with 3 largest mining companies, doing what I call as analytics-led transformation, driving 2 to 3% EBITDA impact, and also very recently working with one of the largest power generators in Indonesia, helping them make sense out of all the data that they are collecting. So what's SparkBeyond? At SparkBeyond, we are an 8-year-old organization. And we started with the basic principle of, AI, machine learning, data analytics. For the layman, it's complex. AI, in fact, today, when I speak to leaders, it's probably the most used and abused terminology as well, right? So we started with the principle of what's the output that you get out of AI? That's solving business problems, business challenges. And the ambition was, can I build a platform, a product, which can solve problems across sectors, across functional domains, And in our existence, we have been successful in deploying this across 15 plus sectors and solving more than 300 business problem statements. We are also privileged enough where we are the exclusive AI partner globally for McKinsey Consulting. And also on the technology side, we are one of the top partners with Microsoft as well.
I'm sorry, Anil. Could just to so we can see your presentation more clear. All right, so you start playing it. I mean, it was not played before.
Yeah.
And please do not forget. I mean, to cue me. I mean, for your polling. Sorry to disturb you. Go ahead.
No problem. So I think some basics first, right? Technology at end of the day is an enabler. If I have to solve problems, what are those three fundamental principles that I need to keep in mind? Without AI, without data, how would you solve problems? I would have a business challenge based on my experience as an engineer, as an SME. I have some hypothesis. Maybe I'll take some data, do quick validation. What if we can design a machine, a product, which can take your data, you can ask the question, and it will provide you the answers, right? That's what we're trying to do. That's the first design principle. Second is, a lot of times, the answers that you're looking for can reside in your data, but can reside in data which is probably sitting with a different function in your organization, like asset management and operations, or it is external to your ecosystem as well. So how do I connect these disparate data sources and build a holistic view, a data view of my problem, and then come up with insights? And that's the second principle in problem solving. And last but not the least is, in this COVID era, we don't need to define the world. What if the machine can adapt in real time to problem statements? So we've been successful in doing this, specifically in the oil and gas industry that we focus. The lighthouse case study that I would share with you is with the largest oil and gas player in Scandinavian region, where we've worked with them for almost more than a year, where they have deployed our technology across 20 plus problem statements, estimating $500 million in impact. Now, why this is unique? This is unique because this is really the analytics-led transformation that I alluded to earlier. This is really taking business problems, empowering the SMEs, the domain experts, the petrophysicists, the geophysicists, the operational people. Now, let me quickly expand, and I'll try to be broad in today's session around what are the potential problem statements that we have encountered in exploration and production. So what you see next is one representation of what a typical exploration journey could look like in offshore as well. So you typically start with doing your basin analysis, you do your fairway analysis, quickly moving to prospect or lead analysis, and then finally I have to look at a portfolio and move into production. Now, with our client, we engaged with the team where before we started, this process typically end to end used to take 6 months. Where we ended up is we are able to now compress this to almost 1.5 months. And it's the same people, the petrophysicists, the geophysicists, who are using the output from the platform and making sense out of it. So what are some of the problem statements? These are around biostratigraphy. So what's my age prediction? What are some of the biomarkers for oil families? What's my burial estimation? Or moving, if you are familiar with drilling and all, then how can I estimate hydrocarbon saturation levels using my logging data? What's my porosity? And finally moving towards production optimization. So I hope for some of you, the participants in today's forum, some of these use cases would be relevant as well. I'll pick two examples for today's discussion. One is on biostratigraphy. Second is on log imputation, and I'll tie it back in an Indonesian context as well. So starting with biostratigraphy. Now, this is a highly specialized domain, but put simply, what am I doing? I have geologists, I have some rock samples, some formation samples, and I'm trying to estimate the age of the age at a particular depth, right? So I want to sort of predict that. Now, how would this process be done typically? Before we entered, the client had a team of geologists, petrophysicists, top-notch talent. They would get the samples, they would look at across their logbook, they would be able to compare it probably to 1,000 different samples and come up with an estimation. A very manual process. B, it was time consuming and which was driving cost up for them. So what did we do? We basically took the historical data that they had, right? So they had, because they had been drilling for more than 30 years across different reservoirs and basins, we basically started taking their historical data. We started looking at what was the output that the geologist himself had estimated as well. We put this data into the platform and started doing two things. One, instead of looking at probably 1,000 different samples, we expanded the universe to look at 60,000 plus different fossil samples to compare again. So I increased my spectrum of analysis. Number two is we were able to automate this process where 80% of the time today, with a certain level of accuracy, the geologist just has to say yes or no to the prediction. Obviously, there are certain edge cases as well where the machine is still not as good as a human being. So there are certain manual interventions that are happening. But purely from a productivity standpoint, if you think about it, the work that I was doing as an individual, which is the emotional aspect of AI to drive adoption as well, is I used to spend a lot of time doing data wrangling as a geologist. I have good background in statistics. Now they are focusing more on the output and expediting the process, driving the cost down. And obviously, compared to what they were doing, there was a 10% improvement as well in the age predictions. Second one that I would like to touch upon is logging data. Right now, logging is pretty standard across the industry. As a part of your exploration process, you do a lot of logging. Now, what are the challenges in logging? Technology itself has evolved over a period of time, right? So the technology that I had at my disposal 20 years ago when I was drilling versus what I have today is different. And why is that important? It is important because your log data is one of the most important inputs when I start looking at my hydrocarbon saturation levels, or even if I want to do my mist pay screening. What we did is, first, we solved for missing data interpretation. So imagine I am drilling vertically or in a three-dimensional setup. I have one reading at 100 meter, maybe another reading at 250 meters as an example. So there is missing data for multitude of reasons. It could be because of issues with the sensor, the drilling equipment, or it could be just the evolution of technology over a period of time. So what we did is twofold. First, we basically created a model which was able to predict or estimate what are these missing values. The approach otherwise would be I would just take the average and have a straight line. So we were able to impute what were those missing values. What we achieved is we were able to reduce the errors in the estimation by 50%. But what did this do? This helped them to go back and start doing missed pay screening. What is missed pay screening? Hey, I estimated 10, but maybe because now I have better understanding of my log data, it allows me to now refine my estimates from 10 to 15, just as an example. Right? And why is this important? This is important because just a couple of months ago, I was talking with the regulator and the state-owned oil and gas company in India, ONGC, where they were thinking about AI applications. And the business challenge they had is exploration is capital intensive. I can deploy my capital. I can deploy today. I will get benefits probably when the field is developed in 5 to 7 years. But probably, what if I go back and see wherever I have underestimated my capacity of existing wells and start driving impact maybe in 2 years, 3 years time. And I think I've seen this sort of an approach on missed pay resonate a lot in the Asian context as well across multiple countries. And I hope probably there's something which could be relevant in the context of Indonesia, where the ability to assess that, hey, I have underestimated my capacity could be a defining factor to boost your production eventually in 2 years or 3 years time. Now, what is the so what of this? Because I have done log imputation, now the client is able to do two things. First is they have an automated exploration pipeline. So this is really saying that there are a lot of decisions that I need to make, like determining the reservoir property statistics, porosity estimation, fluid property estimation. Now, because I am able to impute the missing log data and combine it with a lot of other data sets, this entire process has has transformed for the client and has become more automated, where people, because the machine provides them with explanations and insights of this, they're able to do more business value additive tasks rather than working more on data cleaning and all the wrangling part of it. What I think would be nice is if I try to make this real. So as a next step, I'll try to show you how this data looks like within SparkBeyond. What's the input? What's the output? So what you see on your screen is the web interface of the SparkBeyond platform. This is data from shale gas exploration, which was in United States, which was made publicly available for research purposes. And my problem statement over here is, can I identify the facies, right? So what type of sandstone it is. I have the well name, I have the formation, and your drilling data would look something like this: depth, my resistivity, my pH, PHI, and so on. So you see all of this data is there. And there are two important things to know. One is the complexity is that I'm getting different measures at different depth. And there is also a time component to it. So how does SparkBeyond work as a platform to help you come up with these insights? I take my input data, I just, for validation, I split it into train, test. And this is where the UVP of SparkBeyond, the design principle that I explained, comes to life. The machine is taking all the data. I'm asking the machine the question, help me understand first, what are the predictors for facies of different categories? If you remember what Fajar said at the very start, classification. So this is a classification problem in a way. What the machine does is, in almost 17 minutes, it's exploring 23 million different ideas or insights on the data. It selects the top 100, which are most predictive. And if you are interested in building a predictive model, it goes ahead and builds the predictive model. Now, why is this important? When you talk to a lot of people, AI is black box, right? I'm giving an input, I'm getting an output. The ability to show SMEs, to show engineers, to show domain experts or geologists in this example, hey, you know what? How does this insight predict particular, like no marine sandstone, as an example, is very beneficial, because this is where explainability in AI comes to life. This is where you build the belief. So a quick example of how your upstream data can be passed through the platform, the UVP around coming up with those ideas. A human being would think about 5, 10, 20 ideas. The machine comes up with 100 different ideas. Now, not all 100 would be relevant. So it's important to validate which are relevant. And hence, there's a big difference between correlation and causation. What machine statistics can always tell you is, potentially correlation based on certain approaches or methodologies. Causation is still inferred by human beings. Let me switch gears to production related use cases. So again, in production, typically the type of problem statements we hear from senior stakeholders, from sponsors are, can I estimate or what can I do to increase my oil rates? And by the way, if I know this, I can also drive impact on my procurement planning where I have the right amount of assets required in time, I don't have excess or I don't have shortage. Now, what does this mean in terms of advanced analytics use cases? It could mean I would like to first start with predicting my water cut ratios. Given that I know that, I can then start looking at what's my gas to oil ratio, and then finally go and start looking at what are my allocated rates at an offshore setup, right? What are some of the typical data needed? Your sensor readings, temperature, pressure, valve, your potentially where your sensor positions are, what are your well entry positions, and what's your sort of is if you have done some historical test on where, then we can bring in those values as well. We've tried this, and with the client in Europe, we actually tried the 3 problem statements in a sequential order. We basically built those models. What did they get as an output? First, just from a validation standpoint, we were able to improve the predictions by 60% compared to what they were doing. But more importantly, the business value came because when they were launching the new wells in its first year of operation, the ability to estimate that had a massive impact on procurement and working capital optimization. So these are now secondary benefits of using AI, where you are getting the same output, but the value creation can happen in multiple ways, and that's where the human creativity comes into play. Now, what I'll do is a lot of times when you do AI projects, right, the challenge is you have sort of 3 different personas coming together. You have the data scientists, you have the SMEs, you have the probably the IT people, right? And they don't speak the same language. Now, a lot of times, if I don't scope and I don't do a quick feasibility assessment of the problem statement, the chances of failure are much higher. So we've been working on a new brand approach to say that what if I did not have data, or I don't know what data to look for a given problem statement? How can technology help me in that, right? Now, I'll take the example of gas to oil ratio as an analytics problem statement. I'll run it in 2 ways. First, how a data scientist would approach it, and second, how a data scientist with a SME can approach it to do a quick feasibility assessment of the AI initiative. So what you see on your screen right now is what we call driver discovery. So I have a new advanced analytics data science problem statement. I am a data scientist. I don't know where to look for answers, right? So under the hood, what we're doing is when you don't have structured data like sensors, I'm trying to see how I can take all the information on the internet, right, which is in research papers, which is in news articles, publications, and extract the knowledge or the intelligence out of it. So if I was a data scientist and you told me, okay, you know what, I have a production problem, help me estimate gas and oil ratio, right? I keyed in gas to oil ratio, I ran it, I get some sort of drivers, potential factors which could impact gas to oil ratio. But you know what? This, at least having done it, I know is not that valuable. So what happens if I bring, when I'm doing assessments, feasibility studies, I bring the domain expert or an SME. Just like I showed you in the slide, a domain expert would tell me, hey, Anil, if you're trying to do gas to oil ratio, you know what, look at choke, look at, just type in what type of sensors, pressures, valves, these have material impact. So these are that human driven hypothesis. When I run it, I start getting factors or potential reasons how gas to oil ratio could be predicted or influenced. And I start seeing that, right? Choke, I think at a 10,000 feet, an SME can tell me a choke is important, right? But choke is closed versus choke is open is a more prescriptive factor. Pressure, higher the gas, or like how does pressure impact? Or sensors linearity, repeatability, accuracy, temperature coefficient. Now, what have I done? I had no data. I started from scratch with a problem. I'm using technology to help me overcome some of the structural gaps to getting started. And I'm creating that experience with a domain expert and a data scientist or an analytics professional coming together and trying to bridge this gap. How does this get used? In fact, when we did this exercise with a client, this helped us in two places. Number one, it helped us our data acquisition strategy. A lot of times you would hear people saying, I don't know where to look for answers or what data should I be using. This type of an approach helps us get start faster, helps us understand what data to acquire. Number two, it helps increase our understanding of a particular problem statement. So sometimes out of these 10, 20, 30 factors, 10 are known, but maybe 2 or 3 are new. So it helps you to expand your understanding about the business challenge or the problem statement. And number three, when I'm starting to do the analytics insights creation, I can take these same factors, the underlying supporting evidence, and start creating a knowledge graph or a knowledge model, just going beyond just the prediction or the insights creation. Right? So it's a brand new approach towards problem solving. And hence, when I started with saying that AI is used and abused, but I think one way to think about it is technology is an enabler. You're here to solve problems using platforms, using technologies. And it is more about the methodologies and how technologies will change the experience of user that matters. Now, couple of anecdotal experiences of doing this in Indonesia, right? So I remember in 2017, 2018, I spent significant time in Kalimantan with two different contract miners. And they had a problem statement around cost. So obviously, as you know, coal prices were going down, shrinking their operating margins. And they said, what can we do to optimize our operating margins or EBITDA put financially? We started it by not saying, okay, here are use cases or here are problem statements. We started by building a roadmap to see what are the top drivers of variable cost. And when we did that, we see that, hey, you know what, fuel was almost 30% of their variable cost. Then the next question was, can I influence or can I reduce this cost? And that's the problem statement, the business problem statement we started with. We broke it down into 3 different experiences for the client. Number one, when we set this up.
Baik, Pak Lombok, nanti kita lihat. Oke, makasih Pak Enos. Mungkin itu aja untuk agendanya. Seperti biasa kita ada akan 4 agenda. Agenda pertama.
Yeah, thank you. So when we started, right, like I said, we first identified the business problem. We translated that into an analytics problem statement, used the approach that I just showed you to drive the data acquisition strategy, because the client had no data. Like they had data sitting in silos in Excel files here and there. So what I just showed you helped us accelerate the getting started phase on what data to acquire and store. Then came the analytics or data science part of it, was to take the insights and explain what drives high versus low fuel consumption. But the output was not a predictive model. The output was, with these insights, how can I influence the outcome? And that's where my biggest learning in Indonesian context was the change management aspect, where because we brought the engineers into the process, when we create insights, we validate the insights. By the time we moved into the change management phase, they were already bought in, they understood the importance of it, and it sort of removed the most difficult obstacle in AI deployment, right? The POC trap, as we call it, is building the conviction and running robust change management. So I've done this 3 times at least in Indonesia, and just sharing some of my learnings. To close it off, if you could just help me with answers to 3 specific questions, right? Just to help me understand where you see advanced analytics.
Okay, so we can go ahead with the polling. Is that right, Anil? Okay, so we actually have the first poll here. Please go ahead, Anil. I mean, for the participant, we actually have 1 minute to answer this. Please submit your answer as soon as you can. Thank you.
Yeah. So it's all about, do you think analytics and the approaches that you're hearing today is a strategic differentiator for you? Specifically within oil and gas, the second question would be, where would you deploy, right? Because exploration, the time to...
So, sorry, Anil, I mean, so we're actually going to do one question and then you actually have the results. So, and then we can go to the next question. Sorry about that. Yeah.
No problem. Wonderful. Actually, on this, I'm impressed because I see the conviction level, right? That there's a general belief that, hey, analytics can make and is important. Then maybe moving to the second question is, where would you deploy advanced analytics? Exploration, production, or do you really need to first build a roadmap to understand how would you create value?
Yes, we have 1 minute, please, attendees. You can go ahead and submit your...
This is interesting, Raymond, because...
Yes, this is interesting. And in terms of implementation, expectation.
Yeah.
Hopefully we can get the result soon.
No, I like the fact that there is also some respondents who are saying need to build a roadmap, which sort of typically is a proxy for thought leadership and leadership buy-in as well, right? Then finally, moving to the last one is, what are some of the blockers that you have experienced in terms of adoption?
Go ahead with the third. Okay, there you go. And this one, you can pick more than one. I mean, please.
Yeah. I think for me, number 3 and number 4 resonate well with the second question on the strategy roadmap and the sort of the POC trap, right? Because we keep on doing POCs and past failures. I think I'll hand it over here back to you, Raymond. I think that's all I wanted to share. And thank you everyone for your responses as well.
Thank you very much, Anil. That was very, very insightful again. We actually have a demo of the actual platform. Thank you for that, for sharing that with us. Just to go through the process, I think it's important because a lot of people still see it as a scary process, right? And that's one thing. But I think you catch something that is very important in terms of POC trap, right? I mean, analytics on actually the analytics implementation has been out there for quite some time. And then, of course, the challenge is that there is still a lot of company who's actually still in the modeling or actually POC stage, never get to deployment. So I think thank you for that. We can discuss that further during our panel discussion. We actually have some question already, but first of all, we're actually going to have a panel discussion where I will actually ask basically specify several general questions that we have known to actually be in some people's mind, at least in Iafmi, when we actually discuss digital transformation. These are some of the key questions that they have. And then after the panel discussion, we will do the Q&A. Again, I would like to remind our participants to type in their question via the chat function in your screen photo, and so that we can go ahead and basically address those questions after the panel discussion. So first of all, I would like to actually request Pak Fajar, Pak Philippe, and Pak Anil to actually show your screen or actually your video, so we can actually start our panel discussion with Fajar, Philippe, and Anil. Okay, now this is let's start with the basic one, and I think it's an important one. Why this is important? Because Iafmi is actually an organization of oil and gas experts, right? I mean, a lot of us are basically engineers in exploration and in production. One of the question is, if we talk about mathematical modeling, simulation, that has been used in oil and gas for the last, decades, right? I mean, what really is the difference between those approaches, simulation, programs, mathematical modeling that we actually have done, to optimize our current production, or basically any processes in the industrial processes, and really the data science approach or the machine learning approach that is really the trend, if you could call it now. So I would like to start maybe with Fajar first. I mean, I think generally, not specifically, doesn't have to be specific in oil and gas, but in general, what is the difference? And then I will go to Philippe and Anil afterward. Please, Fajar.
Okay, thank you, Pak Raymond. Basically, the math modeling or the predefined, perhaps, predefined rule based, or the model that already implement in existing environment, it can be complemented by the approach of data science. The difference actually when we can going dynamic, Pak Raymond, when we can going adaptive to the new condition. And when it's happening, the model itself will learn and relearn and continuous learning time by period. So the approach can be complement, perhaps, my perspective. When we talk about the existing approach, I think it's already deliver a value, and the question is how to optimize the value. In order to optimize the value, we have to adapt with the new situation, dynamic, and that's how the model is formed. To relearn and learning and continuous learning to further challenges.
Okay, Fajar, Philippe, maybe you have some input to this before Anil.
Yes, thank you, Raymond, and thank you, Fajar, for this answer. I think one of the things to realize with artificial intelligence is there is nothing new.
Okay.
Everything we do has been done for hundreds of years, for a long time, and it kept on improving over the years. And recently, we have been able to do this work thanks to artificial intelligence quicker, better, faster, which allows you to take the right decision faster. One of the important things which is happening with artificial intelligence is we used to be working with physical models that we understand. You can write the equation, you can model how the system is with the equation, with something which is very defined, deterministic in the physical world. And then we kept on improving those equations. With database approach, we're changing concept a little bit, where we are listening to the data to try to understand what the data is telling us. And that is one big advantage, is that with this approach, we can complete and complement everything we were doing before with physics-based approach, where we knew what the models were, where we knew what was happening, we understand it, we could write the equation, because those patterns, those algorithms, those knowledge of physics are understood. But there's still many things in our world we don't know. We don't really know why things are happening this way or that way. But if you record the data, even if you don't know the equation, the data represent that equation that you don't know. So if we listen to the data and understand and analyze the data, that allows us to complement what we are already doing quicker, better, faster with AI compared to the way we were doing it before. And then we add this level of complexity or simplicity, depending on which way you look at it, where we can actually start to look at things we don't know about. And AI allows you to look at what's called the unknown. You don't know what you don't know, but AI actually knows it and helps you solve it.
Okay. And that's another different perspective and good insight on that, Anil. I mean, your input to this?
Sure thing. So I think Philip summarized it well, right? Fundamentally, there are two ways of reasoning. One is deductive, which is what Philip represented as writing physical equations, mathematical models. The second approach is inductive. Now, deductive means breakthroughs take 10 years, 15 years. The evolution is slow. When I take an inductive approach, the chances of me finding something new or breakthroughs are much faster. So what has changed? If I take my example, in university, what we used to learn is MATLAB, R,
Right.
even SAS, right? What is the fundamental
Right.
difference? I would have one simple Excel file type of a data, right, where I have
Right.
one variable where I want to predict something, I have some other columns, and I was
Right.
limited, right? So that's what I would be using to produce an output. The mathematical techniques, probabilistic, linear regression would be the same. What has changed? Purely because your cost of compute has gone down, your cost of storage has gone down. Now you have the
Right.
ability in an economically viable way to brute force or to deploy large scale computing on the same data, but go more granular. For example, taking second level sensor readings, which traditionally in traditional systems, the cost would be high. You could probably not even use it, right?
Right.
So if we see there are some structural changes which have happened,
Right.
which are also enabling that change between a traditional approach versus data science approach. To summarize,
Right.
it's the difference between deductive versus inductive at the end of the day.
Okay. All right. So I think what data science and analytics brings you don't have to start with an assumption when you actually start with rule based, right? You can actually have the data speak for you. And I think that's the summary of it. I mean, if I may, doing that now, I mean that begs to the second question, right? So it is a collaboration, right? I mean, you actually have the SME on one side, and then this new data science, machine learning expertise on the other side. How does that work in real terms, right? I mean, is it basically two separate groups working on separate room? I mean, one basically providing data to the other and the other basically providing answer to the other one. How does SME works together with the data science team? Or is it really basically the expectation going forward is that for all SMEs to understand data science? So I'll start with Philippe on that.
So I think the SMEs need to understand data science, but not to the level where how it's done. They need to understand what data science can bring to you in the same way that you are using MATLAB, Excel, PowerPoint, a CAD tool. You know what it's doing. You don't really care how it does it, but you know how it's doing it. Now with all these new tools on artificial intelligence, you know what those tools can do for you. And so you use the tool to make it. So the SME need to know what his problem is and need to know which tool he can use to solve a particular problem. If you need to do a presentation, you need to use PowerPoint. If you need to analyze some data, you're going to use AI on whatever tool it is. We call it Darwin, SparkBeyond as SparkBeyond, I think, tool. Whatever works for you for your particular project, but those are tools that you can use. And the data scientist inside of the data science, inside of the client operating organizations are very important at the beginning of the project to make sure that the project gets defined and organized properly. Once a project is working, there's really a tool on a subject matter expert. The data scientist can go and work on the next project, on the next challenge, on the next system of operation.
Okay. All right, Anil?
Sure. I think one word, right, and Gartner has summarized this very well, is the word of citizen data scientist, right? And if you think about today's SMEs, if you upskill them to become future citizen data scientists, right, that sort of is a crucial element. And why is that, right? Because as you saw in today's conversation as well, there are tools, there are methodologies which are bridging the gap between data scientist and business impact. Now, the SME validation still remains very important, right? So while a data scientist is still required, they are a precious commodity, small in numbers. Imagine like one of my customers is AB InBev, the world's largest beer manufacturer. They have this problem. They have a center of excellency where they have 50 data scientists, but they have so many business problems, right? So our experience has been where with the right technology, if you empower the SMEs to become tomorrow's citizen data scientists, low impact but large number of analytics problem statements can be solved by them. Then there are weird, tricky problems or greenfield problem statements where you bring in your precious commodity, which is data
I
science,
see.
and you bring in your SMEs to do the translation with them. That's one setup, at least I am seeing, which is working
Okay.
in the marketplace.
Okay, and I think Pak Fajar, I mean, I think for Mas Fajar, this is exactly why Iykra exists, right? So I'm really, I think we're really interested to understand your perspective on this.
So yeah, just refer to my encouragement ya, Pak Raymond ya. How
Yeah.
to broke the perception about how data science is only for data scientists. Yeah.
Right.
No, I also found the community data science, but I'm not trying to make it exclusive for data scientists. Because if you make it exclusive, the field will gone. Yeah. So
Right.
the thing is, data science is should be learned also by the business business people or the engineering people, perhaps. Yeah. So the translation that Anil referred to is can be doing by business or perhaps on the data team as well. So when we learn the similar concept of data science, business learn it, data team learn it as well. The translation process can be easier. Yeah, it can be easier. So the first thing first, when we start the data project, we need to hypothesis kan Pak Raymond ya. Artinya we need
Okay.
to find hypothesis first, then testing evaluation. The hypothesis creation is the hardest part because we need starting from one the business concept that we need to do to optimize. So
Right.
basically, that's we want to encourage and re-educate about data science. It's not only for data scientists. It can be also analytic translator, like what
Right.
Nick previously researched. There's a role not on the business side 100%, but some
Right.
part in data team, the analytic translator, and it's quite rare here in Indonesia, Pak Raymond.
Right. Right. So I think what we're saying is, I mean, data science will be just like statistics to the engineers, right? I mean, if you're an engineer, you need to learn statistics, then you need to understand part of basically what data science is. I mean, as an engineer going forward, I think that's you can summarize that as one thing. So now, this is one of the other things that actually has been discussed quite frequently, basically in the SME world, is that data science can become a black box, right? I mean, it's a big machine, an engine. You put your problems in, it gives you recommendation out, but you cannot really explain it. You cannot really trace it. Trace the solution from the problem or understand the solution. And of course, in oil and gas, where you're actually operating multi-million, hundreds millions dollars of operation, I mean, with high safety integrity, right? I mean, that is a very big concern. Any feedback or input on that? I mean, with regards to how AI can actually also do the explainability or traceability of the solution that it can generate from the problem that is being provided. I'll start with Anil on this one, and then I'll go to Philippe.
Thank you, Raymond. So you made an important point, right? I think it's not only about integrity, but it's also about ethics in AI, right? I don't want my AI systems to discriminate. Imagine if you've what happened 3 years ago when Microsoft released their language translation bot, and within 3 hours it went racist, right? And Microsoft would pull it back. So the question is in a methodology and a process, right? So for example, what I showed today. What's the traditional machine learning or even a traditional analytics process? I take the data, I prepare one file. Like first step I do is I evaluate a model performance. Then I look at, okay, what is driving that model performance? I'm starting with a black box output as the very first step. What we aspire at SparkBeyond to do is take your raw data, get all the insights first. and validate these insights in building a predictive model. Now, why is this approach different? Because it structurally solves for trust. It structurally solves for ethics when you're deploying AI systems, right? Because I'm going, it's not only about the prediction, but what can I do with the prediction, right? So if I can explain the prediction by controlling the insights, not the raw data, then I have more belief in the AI system eventually that I develop.
Okay, all right. Philippe?
Thank you, Anil, for this very good response. To me, I think to really answer the question, we need to go back a little bit in time.
Okay.
You know, AI was created in the 50s, and we had what we called AI 1.0, which was a lot of theory and very little practice, until the 1980s when we went into AI 2.0 because there was more hardware available, you know, computers became a bit more available worldwide. And then in about 2012, 2014, somewhere on that time frame, we went to AI 3.0 with the arrival of the cloud, of Hadoop, Kafka, and many other technology, Darwin. And so since we entered AI 3.0, we have not reached a plateau. It's moving very, very quickly. And one of the things of AI 2.0 was this black box approach, where you didn't know what it was saying. But with AI 3.0, there's been a very, very strong effort to go toward what's called explainable AI. So that when you make a prediction, you make the prediction, and this is why we are making this prediction. This is why we're saying you should do that. So the SME can look at it, go back all the way to why we are making the prediction and saying, oh, I see why you're making that prediction. It makes sense to me. I understand it. Thank you so much, system, for telling me this information. And that brings a very important point about artificial intelligence is you may have tried it 5 years ago, 10 years ago, 5 months ago, and was not able to fix a particular problem. But we are able to fix, we are able to solve challenges with AI that we couldn't solve 6 months ago. And in 6 months, we'll be able to solve problems we're not able to solve today. So this explainability is one of the things that got pretty much solved 3 years ago. If you are not getting explainable AI from your provider, you need to question your provider. Why not, you know, change provider? But, you know, all the modern providers of artificial intelligence are providing explainable AI.
Okay. Mas Fajar, I think that's one of the challenges also that you are facing in actually socializing data science in Indonesia.
Yeah, refer to the interpretable AI, Pak Raymond. It's challenging on some of industry. For example, banking and financial service. There is different approach when banking building credit score model and fintech. Fintech be more agile. Fintech can develop any model that they want to use, and even black box, perhaps. But in banking, they have a rule to understand the process and the variable. So back to the root, the grandfather of machine learning, like what Val Harian, the chief economist in Google, said, that the grandfather of machine learning is actually the regression, Raymond. And the regression is something that I learned when I in college. My background is economic. Actually, I learned in econometrics. When you want to develop the model or the running the regression model, you have to develop a theoretical first. You need to find the philosophy, and then going to mathematical model, and then running the regression model. So back then, when we developed that kind of approach, we know exactly how the variable is input in the model. But there is some new approach, or the I don't say it new, but there is some approach that quite black box that defined by the AI itself. So nowadays we have some term, we call it XAI, explainable AI, interpretable AI, how to decode the black box, Pak. So it's a way, basically the black box one, it can be it might more accurate by far between the traditional one. But the challenge is how to define the variable. So nowadays there is approach and the technology to interpret the model into some the process, the step-by-step process. So it's happening, yeah. XAI, explainable AI, the interpretable AI on the black box model
All right.
to decode into the process step and the variable.
Okay.
So when it defined, perhaps some major sector like banking, telco, financial service, no can accept it as the process. So it
Okay.
can now.
All right. So I think what we can summarize is, I mean, so explainability, interpretability is also a focus of AI development. Not only that is, it has to be able to be fast and to be able to solve problem, right? And as what Philippe is saying is that, I mean, if you are an AI provider, you need to be able to explain it. I mean, to the SMEs, which is important. Okay. So let's go ahead and do the question. We actually have 3 questions coming in. The first question is from Pak Nanang. Basically, it's actually 2 questions at one time. First of all, is what oil and gas company in Indonesia that have implemented or in process of implementing AI or machine learning, specifically for predictive maintenance? I think that's the first question. If basically the speaker can share what they're doing or what their experience before. And then second is, there seems to be the need to have a clear vision and mission. I mean, to do the digital transformation or the analytic-led transformation, especially from leadership, right? I mean, is that true? I mean, what is your experience on that? So I'll start with Philippe again on this one. So the 2 questions, Philippe.
Thank you. I missed the second question, so you may have to restate it differently. But the first question, we have confidentiality agreement with our clients, so I cannot give you names. But I can tell you where our headquarters is for Asia Pacific. It's in Tokyo. Right. And we have branches with our partners in Indonesia and in Malaysia and Kuala Lumpur. So hopefully that gives you some ideas of countries where we operate and who we want to operate with.
Right. I mean, the second question is actually the leadership buyout. Is it a technical problem, or does it need to actually have a leadership buyout? I mean, from the client or user side in order to be able to effectively implement AI?
So leadership is very important. I mean, ultimately it is a change management, and you are going to have the support of your leadership. This being said, if you look at cybersecurity, typically the IT organization can choose which cybersecurity products are going to be using, and an AI-based product is not more expensive than a traditional non-AI-based support tool. So you don't really need to have this, leadership buy-in. But if you want to do something a bit more transformative, such as doing predictive maintenance based on AI, it's a little bit like buying insurance, because you think you're going to be able to gain something, but until you gain it, there's no real way to prove that you're getting this value. So it's absolutely needing to get the leadership support for many large AI-based projects. And you look at the return on investment on those projects, it is so large that typically the leadership gets very quickly very interested.
Okay, thank you, Philippe. Pak Fajar, I think maybe you can share some of your what you're doing in terms of AI. I mean, I guess the question is oil and gas in Indonesia, and also leadership buyout or support. I mean, for AI implementation.
Perhaps for question number 1 is regarding the predictive maintenance that I can share previously in my expert portfolio in my company now is working on some manufacturer company, Pak Raymond, ya, to prevent or predict the failure on the machine, yeah, because the cost of the replacement when it fail on spot it's higher than preventive. But back then in 2016, when I work in Teradata, there is one of our client in global and regional and it's already stated in the website. If you are looking, if you are want to looking for the detail, this oil and gas company also implement the predictive maintenance to analyze the drilling bore, the diamond on the drilling, how to ensure not crack on the spot. So I think I can share because it's stated in the website is ConocoPhillips Raymond, yeah. So it's 2015, I think it's already sorry a while ago. So regarding number one is something that really also we looking for to explore, analyze the data of sensor and log in one of the forest in Kalimantan. It's relate with the predictive things, yeah, in sensoric data. The question number two, can you
I mean, basically leadership support, is it required?
Okay. So basically the approach of data science project is coming from two approach, bottom up and top down. Yeah. Bottom up is coming from the team proposed initiative and hopefully accepted by the boss. Yeah. But from my experience, the faster is the top down. So
so you need leadership.
For sure. Leadership for speed up. But can our leadership can be convinced by our process and initiative? It can be make sense on the process, but it take longer time. But leadership to buy in, then it speed up the process.
Okay, Anil, any last words on this one?
Absolutely. So, well, I can't name the customer, but specifically in oil and gas and in Indonesia, I know that like we are part of early stage discussions on rotating equipment maintenance, your pumps. That's the short answer. We've done, and I think more than predictive maintenance, at least what I've also seen is condition-based monitoring and increasing my asset lifetime. I think those are also low-hanging fruits which you can pilot AI-related problem statements, pretty straightforward. Done extensively in mining and power. Now to the second question, I think, yes, that's how it has to happen. Leadership is important, right? Unless you bring this and table this all the way at the BOD level in Indonesia, at least things don't move, right? So it's absolutely important to get the buy-in from the management, not fall for a POC trap, and then build a roadmap. Don't say we will do a POC for 3 months, right? Build a roadmap with the right rail guards to say that stage 1 is 3 months, stage 2 is 6 months, stage 3 is something else. And finally, index on capability building, because what you want to do is if you're investing, managements always like to hear that it's not only bringing in a vendor or bringing in a partner. How are you going to create strategic differentiation for yourself? So at least in some of the conversations in Indonesia, it's not about building a model or it's bringing in a vendor who provides services. What is important is management reacts very well and buys in when they hear capability transfer and ownership of the output. And those are key things when you table an AI-related proposal, at least in Indonesian context. I think leadership reacts positively.
All right. Thank you for all that input. And we actually have our last question and it's perfect with timing. We actually have talked about basically AI application in operations and maintenance. What about development? Specifically, for example, AI, how effective will AI or machine learning be in, for example, in EPC project development? Or because it's a short project, I mean, it's really difficult to implement that. So I'll start with Anil on this one.
So I think EPC projects, right, is a bit of a virgin territory because some fundamental characteristics are changing. Now, one place where we have tried this is with a player in London around, they basically manage maintenance for sewage plants, water treatment plants, and pipes, right, at different points. So they have to come in short-term construction of extension of the network. And then we've seen some success, but again, over there, more than predictive maintenance, they have taken the lens of condition-based and more a rule-based engine for a short duration.
Right. Okay. Philippe, any experience or input on that application?
Absolutely, thank you, Raymond. So when we look at EPC and engineering challenges in general, there is really two places where we have seen a lot of value for our client. And here we are moving from what we call structured data, thing you can put in an Excel spreadsheet, to unstructured data, which is a lot of information coming from many places. So when you have unstructured data, which is what we have in engineering a lot of time, then we switch from the type of tools that we have seen before into natural language processing in order to analyze all of this information and make sense of it and come up to some conclusion. And so there is two places where we have seen this happening at scale with a lot of success. The first one is scheduling. You have all these events which happen, and you need to optimize the scheduling, and AI provide a fantastic way by using natural language processing and complementing. Once you have structured your data through NLP, then you can use some structured data tools on machine learning. But the first thing is to make sense of all of this information. The second place where we have had a lot of success with engineering problem is the amount of documentation that you need to read, classify, comply with, make sure that you comply with all the specifications and understand what every subcontractor is providing to you, how do you manage all of these contracts. Once again, natural language processing allows you to match those requirements with the contract and what is being delivered. So when we go to engineering project, it's not as much predicting what's going to happen as much as understanding what's available, what we have, and trying to make some decisions. So scheduling optimization and compliance to contract is two places where natural language processing brings a lot of value today.
Okay, thank you, Philippe. And Mas Fajar, implementation of AI on short projects.
Short project, you mean the POC one?
Yes. Well, no, basically for capital project, if you are building, for example, implementation AI, if you are actually building a facility or building a house, is there any specific implementation on that, or is it only applied to long-term operation type of activities?
Yeah, actually, in terms of the AI application on the what perhaps I can refer the thing that I mentioned previously in Kalimantan, yeah, in the forest area. It's regarding the carbon trading service area. Actually, the challenge is not only to apply AI in the system, but also enabling the system through the full environment. Yeah. The challenge is network. The challenge is in the sensor, yeah, enablement. So regarding the network, we actually extend our service into the open run activity. So what we think is, and when we talk about the implement AI, it's not only the modeling, yeah, but the preparation, the environment, and how to make sure the system is running well to cycle back into the production and operation. So it's not stop on the modeling, because I think the modeling is perhaps not the easy part, but it's the most simple compared to other activity. Yeah? So what we did in Kalimantan, we enabling even the solar cell first. We enabling the network first to ensure the data transfer speed, and also the consumption of data is under the solid pipeline from data point, data source, process, output, cycle back into the production in a process of forest intelligence. So basically what we experience is most of the application, not only on the Kalimantan, but most of the process in the AI application is taking part more on the preparation things, Pak Raymond.
So basically talk about infrastructure, right? Of course, the infrastructure for the data has to be there, before, for basically.
Infrastructure have to be there.
Yeah. Okay, I think thank you very much. I think I would like to actually thank all three of our distinguished speakers. I mean, for taking the time to actually talk with us and actually present, share, and also discuss a couple of key issues with us. I would like to thank all the panels. I mean, all the attendees. I mean, to actually listen of the sharing and also ask some question and actually participate in our polling. With this, I will return basically the screen to Ibu Desi. I mean, for the next session. Thank you very much, everybody.
Raymond,
Thank
if you don't mind,
Yeah,
I'll give one closing statement.
Go ahead.
Which is, with today's modern tool with artificial intelligence, it is relatively easy to demonstrate that any data challenge can be solved with artificial intelligence. That's why we see so many POCs around the world solving all type of use cases. Scaling up those projects is what is complicated. And this is where you need, when you speak to a provider, please ask for what type of large-scale projects they have implemented, because this is a difficult part with artificial intelligence. Thank you very much.
Basically deployment, right? I mean, to avoid the POC trap, like what we mentioned earlier. Okay.
Exactly. Yeah.
Okay, thank you. Thank you, Philippe, for the last word. Thank you, Anil. Thank you, Pak Fajar. I'll return it to Mbak Desi. Thank you, everybody.
Thank you.
Thank you.
Thank you very much for all the speakers from the session 1, and also for Pak Raymond for smoothly moderating the session. Now we are going to our second panel discussion, and I would like to introduce our moderator for the session, Bapak Edwin Badrusomad. Bapak Edwin Badrusomad is currently a senior manager for project services in Medco ENP Indonesia. He also served as in the advisory board of Iafmi. He has more than 30 years of career in the project and construction sector, and he graduated from civil engineering in construction management. So with that, without further ado, Pak Edwin, the screen is yours.
Okay, Bu Desi, thank you very much for the introduction. And to all the attendees and also the speakers, good morning, as it is still in the morning. And Assalamualaikum warahmatullahi wabarakatuh. And today it is very interesting that we have had already first session on the discussion of AI and machine learning, and talking about the power of the data science for the industry of oil and gas. And on the next second session, we will have three resourceful speakers as well, that we are going to more optimize the availability and the science of the data for the oil and gas. But what we are going to talk about is the digital twin. I would presume that this is the other development, the other improvement of the data itself, the data optimization itself for the industry, not only the oil and gas, but lots of industry. But now today we are going to talk about the oil and gas industry. And digital twin, this is something that coming into the world, the oil and gas industry, that we can really optimize the this digital twin technology for the project, for the operation and maintenance as well. And today we are going to talk about that. You know, we can see that from the first session, the data is really one of the key in our life, including the industry of oil and gas. And there is one other thing that talking about this data, that when we are talking about the operation, when we are talking about the project, when we are talking about the oil industry, oil and gas industry, and when we are talking about the digital transformation or digital platform, we have to shift our mindset about the document to the data, because data is something that we are going to use as the source for this kind of improvement in this industry. And one of the big issue with us is, of course, the availability of the data itself. It is including on the operation. One of the big issue in the operation is the data itself. Now, today we are going to talk about the digital twin, and we are going to discuss, to explore and know more about the digital twin for the implementation for the oil and gas industry. We will have 3 speakers here. Pak Hiroyuki Takeshita from the Dassault Systems, Pak Segaf Husein from AVEVA, and Pak Abdullah Wahb from GE Digital. These 3 technology providers are well known already in the industry industry, and we would like to start first with Pak Hiroyuki Takeshita to talk or to present your presentation. You will have about 25 minutes presentation before we have another presenters and Q&A and discussion. Pak Hiroyuki Takeshita is a Solution Experience Director, Energy and Materials from Dassault Systems. He is responsible for defining industry solution experience for optimized plant construction in global energy and material industry team in Dassault Systems. And since 2012, besides defining the solution experience, Pak Hiroyuki has been involved in supporting projects worldwide and incorporating the experience into the solution experience. So this will be interesting to learn from his experience. And he joined Dassault Systems in 2008 as an industry consultant and also solution specialist. He has been involved in different projects in energy, process and utilities industry, shipbuilding industry, and construction industry. Before joining Dassault Systems, he worked in EPC from in Japan. He started his career as a mechanical engineer and involved mainly in Middle East projects, and moved to engineering IT domain afterward. So with the background in project in the energy and now in the IT, I think we will learn a lot from Pak Hiroyuki. He graduated with a master's in mechanical engineering science from Tokyo Institute of Technology. And now today, Pak Hiroyuki will present the digital twin to accelerate the digital transformation for upstream oil and gas from design to operation. So Pak Hiroyuki, the screen is yours. You can start your presentation, please.
Thank you, Devin. Sorry for my long profile. So, okay, so thanks everyone. Thanks for inviting me to this webinar. So my name is Hiroyuki Takeshita, coming from the Dassault System and energy and material industry. Today I'm gonna discuss about how digital twin technology can drive operational excellence. And before I start, let me talk a bit about the Dassault System corporate profile. It shouldn't be wrong. So we are Dassault System, the company in Paris, and our headquarters is in Paris. And we are the software vendor dedicated for the science and engineering. We are not the generic IT company. We are focusing on the science and the engineering. We have 20,000 employees all over the world. Myself located in Tokyo, Japan, and even in Indonesia, we have offices in Jakarta, and we have 12,000 partners all over the world, and particularly in Indonesia, and particularly in the oil and gas sector. We are working closely with Navita Oligo, and we have almost 300,000 of the customers all over the world. And then our company started our business in the 3D design. It was 1981. We started our business with aircraft, the 3D component design. And after technology evolved, we eliminated the physical mock-up. Everything is the design and simulated in the digital, and the customer didn't need anymore the physical mockup before they release any product. And then in 1999 we started this concept called the product lifecycle management. Here we developed a lot of the solution and a lot of the technology acquired, and then we support lifecycle of the product, starting from the design and the manufacturing and the operation and maintenance and disposal. Since 2012, as we developed a lot of technology and acquired a lot of technology, we changed our strategy. Rather than focusing on particularly on this manufacturing industry, we provide all these available technologies through the one single platform and serve our industry to resolve the business challenges. So now our solution is not particularly for the manufacturing industry, but to resolve the business challenges in all the industry. And then what is the technologies we can provide you through this 3D experience platform. So today's topic is more about the digital twin. So as we started our business with the 3D, so obviously we provide the 3D with the power of the 3D. You can even simulate how you can build up, or if it is in the operation and maintenance, how you can maintain it. So and then if you have
ada dibolehkan nggak? Dibolehkan.
Yeah, excuse me, there's someone there is unmuted from me. So okay, so anyway, let's go on. So yeah, if the 3D is available on your hand, that's fine. But particularly for the existing the facility, unfortunately we don't have the 3D model. In that case, is no worry. We just take a laser scanning and bringing the point cloud, and we can provide you this digital twin as well. So particularly in this in this time, so what's expected in this digital twin is not only the 3D representation, but we need manages all the relevant information, including the drawings and the document and the calculation, the link to the digital the asset. And then in the digital twin, the integrating the IIoT data and the analyzes it through the machine learning technology or the AI technology, which is discussed in the previous session. And then the predictor, of course, the near time future, which facility is fair, and if possible, we will take the preventive actions. And then we need through this platform, we even provide the technology to simulate and the model each of the operation the operation process operation, and in the ramped parameter way, and connecting each operation together, and we can simulate even the process as well. And then obviously this contribute to the the optimizes your operation and the process as well. So these technologies are available in the single platform, and then we're gonna serve our industry, our customer, with the digital twin technology. So let's look a little bit about what's happening in our industry. So I just grabbed this graph from the High Pressure Gas Safety Institute of Japan, and as you can see here, obviously since 2001 blowout and leakage is in the uptrend, like this. So obviously the one of the major causes facility is start aging. And then of course the people are also aging. So the more than ever, industry is expecting the digital transformation technologies contribute to resolve this the issue we are facing currently. Obviously this the increasing the accident will sacrifices the safety and also the availability of the facility. So some of the country started to giving or the motivate our customer in our industry to apply this kind of technology. This is one of the example coming from the Japanese system, which is called the super certified plant system. I don't go through each of the topics in detail, but basically the more, more utilizes, the big data and applying the digital technologies and changing the, the maintenance paradigm from the corrective, the maintenance to the preventive maintenance. And, we need increases the safety and availability of the facility. That is another objective of this super certified plant system. This is not just encouragement, but, the government is giving the, the customer real incentive with that, which means that if the customer is certified with this the super certified plant system, the owner operator is entitled to decide the turnaround maintenance duration within the 8 years maximum duration. Within the 8 years maximum duration, the customer is entitled to decide the turnaround duration. By the way, today this is the more about the digital transformation, sorry, the digital twin technologies, but the Dassault system ourselves and particularly myself is responsible to define the turnaround management solution as well. So if you are interested in what we can do for this turnaround management, please contact me as well. So from the corporate perspective, many of our customer, in oil and gas industry is aiming at the operational excellences. There are lots of the definition about the operational excellences. However, it boils down into the 3 key the pillar in our industry. Nothing but it's a safety and availability and efficiency. It's simple, right? So safety is our facility, particularly in the oil and gas industry. We are handling the toxic material or dangerous material. So we need to ensure the safety of our facility to protect our employee and the external contractor and the local business as well, right? So without safety, nothing happens. So next, the key pillar is availability. In the super simplified manner. So our business is pretty much simple. We just put $1 billion in front, and after that, we keep our facility, up and running. Then each day, we pay back, the initial investment. This is, the simplified manner, our, the business. So availability is directly impacting, our KPI, our, the finance KPI. So efficiency is nothing but if we wanna, be at competitive in the market, we need, the produce more with less material and with less energy. So, the digital twin should contribute to these, the key 3 pillars of the operational excellences. So, from that viewpoint, we believe that the digital twin for oil and gas industry should provide this set of the, the functionality or the capability to contribute to either of these 3 key pillars: safety, availability, and efficiency. So if you want to say that our facility is safe, you have to prove that. There are a lot of the safety good practice and the regulatory requirements. So we have to ensure that our facility is in compliance with all these safety requirements, regulatory and best practice in the industry. So if you want to prove that our facility is safe, you have to ensure that all your facility configuration information is up to date and represent our physical facility correctly. It is including the object tree, engineering data and document and 3D model, including the more than that. And then unfortunately through the turnaround, we implement the MOC management, the changes project. So we have to manage the change properly. Otherwise, your digital twin get obsoleted. Very often, the people forget about the importance of the change management. So you just set up the 3D model in the beginnings, and then after that you maintain it, and it get obsoleted. We should avoid it. And then if the structure simulation and the calculation, this is the kind of the evidence, okay, so our facility is safe. If you want to say our facility is safe, you have to keep all the calculation and the structure simulation ready to present to the regulatory body. And if you introduce any changes, you have to rerun the simulation and the calculation and update it. And then if the regulatory body asks you, you have to show the operation and the maintenance history immediately. And to contribute to the safety, workers' safety and industrial safety, once you get the 3D representation digital twin of your facility, obviously that you want to simulate your construction and modification, major modification, before you go to the site, that you want to plan and simulate your safety, the in front. And then to contribute to the efficiency, digital twin should be connected to the the energy simulation and process simulation, and then run the optimization. Many of our customer is in terms of this digital twin, we focus more on this the process simulation and the energy simulation integration. And then the data integration, in the narrow definition, the digital twin, the 3D model integrated with the real-time, the IoT data, the very often this is the narrow meaning, narrow definition of the data integration. Of course, we should do that, and that we have to visualize this real-time, the status of the facility as well. So these are the set of the the functionality, which is in our understanding to be required for the digital twin to contribute to the operational excellence of our customer. So let's shift our view from the other the angle, that is the digital twin is not a kind of the independent the digital system or data system itself. It is to be positioned as a part of the plant operational system stacks. That this picture is coming from the ISA 95, the control system integration. And in our understanding, it is digital twin is to be positioned at the level 3 in this plant operation system stacks. Together with ERP and EAM and the DCS and the data history, and these the stack of the system the integrated closely and work together. By the way, there are some of the report coming from the US the energy the process research institute or something, and then the ERP system and EAM system, and then the digital twin and these DCS system. These the four system the core business of the large capital facility customer. So here I present in the real implementation how the digital twin can be positioned among this the plant operational systems. As I say, ERP system and EAM system and the digital twin. These three sets of the information cover the core business process of the the capital facility owner operator. Of course, together with DCS and the data system PLC, it could be a PLC. But one of the the use case would be something like rather than going to the the facility physically, the operator the walk around this digital twin and finding the real-time status of the facility, and if you find anything, you report directly to the EM. We could be the action report or condition report, the whatever we call it. The depends on the EM system. The way to call it, it's different. But the once this condition report or action report is filed in the EM system, that we have to analyze each pieces of the the issue reported against, and then it is required, if it is required, the engineering modification is the flow back into the digital twin, and here we manage the the management of the changes, and together with the management of the changes, that we have to the simulate how do you implement these the changes and designed in the MOC, and it flow back into the enterprise asset management system as a work order, and we implement it. And immediately we have to update facility configuration information, particularly this equipment master or the functional location should be the synchronized back into the EM system. Yeah, this is just the one typical the use cases in the digital twin integration with EM and the ERP. But here I want to say is that the digital twin is not independent solution. It is to be positioned as a part of the plant operation system stacks. So, here, I want to show, some demonstration, how it looks like from the user perspective, this digital twin in our, the Dassault system, how it looks like. So, here I want to, highlight the three key points, three key elements. In our, in my demonstration, I particularly focus in the, these 3 points. First, it's a 4D differential. Okay, so the plant facility is changing its configuration day to day. Particularly, for each of the turnaround, we implement the changes. So, if something changes, the 3D representation should be changed. We have to track all the history of the changes. And then, not only this, the facility itself, but also we have to, track what is the maintenance and what is the work of the executed in past, and in context of each of the maintenance order or the work order, we want to show that in this context, what facility, what function location, or which the equipment is the maintained or the modified through this operation, and who is the personnel the assigned to this operation, and which construction equipment or which resources are assigned to this operation. And then that we have to the track in past, that if something happened, that we have to date back to the past, and then that we know that what is the causes of this the current problem. And then as we already discussed in the previous slide, so this digital twin should be positioned as a part of the plant operational system stacks, and we have to connect and aggregate the information and represent all the relevant information through the digital twin technologies as well. So in my presentation, in my demonstration, I want to a little bit focus on this, the changes of the configuration of the 3D representation through the time. So here, what you observe in the video coming after this slide would be something like in the beginnings you don't have all the facility, but after the first turnaround you capture the ground floor of the facility. Of course, if you have the sufficient money, you just take all the facility as the laser scan. But if you have a limited budget, that you just take the first ground floor, and then in the second turnaround you just run the next campaign, and in the end you acquire the complete digital twin of your facility. So let's look at how it works. In this user interfaces, above you have a calendar, and then you have a 3D representation below, and if you slide forward and back, you see that the representation below will be the changing depends on this calendar. And then in this calendar, you can see that the work order or the maintenance order, the captured from the enterprise asset management system are all shown listed here. And if you click on the maintenance order or the work order, which personnel and which the equipment is the maintained and assigned to each of the maintenance order or the work order will be the represented here. Obviously this information is coming from the the external system, like the relevant document. It's coming from it's actually available in this digital twin, but at least the personnel information and the coordination of each of the person at this point of the times, this is all captured from the external system, like real-time location system. These days people are wearing the the GPS and the Wi-Fi, so from this technology we can even capture the the coordinate or the location of each of the people. And if the everything can be represented in the 3D, that's fine. However, there are some limitation digital twin can the capture as information that is for example, if the stranger or intruder coming into the site, the digital twin cannot represent. And then if you want to capture all these information as well, you can put the CCTV camera here and there, and all this information can be integrated. And if some problem happen, trouble happen, at some point of the times, to analyze its code, you can data it back, and that you can see what happened in past. Okay, and then this is a conclusion of my presentation. Okay, the digital twin is to be designed to contribute operational excellence in terms of the safety, efficiency, and availability. And to do that, or for that purposes, the digital twin technology to comprises the following element, like the basis of the permission and licenses, and the construction and the maintenance simulation. Okay, so to ensure the safety of the personnel, construction personnel, you have to simulate and plan your construction, and the major maintenance activities as well. And the process simulation and the energy simulation should be integrated together. And the data integration with EM system or History or the data, the PLC, DCS system. So these are the major the functionality expected from the digital twin technologies. And in the end, I wanna re-highlight the digital twin is to be not independent, but this is to be positioned as a part of the plant operational system stacks. That is, the conclusion of my presentation. However, before I close my presentation, I want to trigger the poll question.
Okay. Good. Okay, the poll is there already, so you can just click on the yes or no based on the question number 1 there, and then after you click the yes or no, then you can just submit it. Okay, hopefully the result can be presented now.
I cannot see the result.
Here is Hiroyuki.
How I can see the result?
Well, that is about 97% yes to answer your question.
Okay, great, great.
Yeah.
Thanks for that. So if you are interested in the digital twin as a part of the operation system stacks, please contact our partner in Indonesia, Navita Origo. All the contact information is given here. So I hope in near future, that we have a chance to talk more detail about that. By the way, as I introduced in the beginnings, we are also promoting our the solution to address the turnaround as well. So if you are interested about the comprehensive solution to manage the turnaround, please contact about it as well to Navita Origo. Thanks for that.
Okay. Thank you, Pak Hiroyuki. I think it is a really interesting presentation. And I would just sum up that the digital twin for the operation, it is basically started with the base of the 3D model, I would say. So you start with the 3D model. And after that, there's supposed to be also some data sources with the different data that need to be integrated into the digital twin. And having the digital twin, then we can predict early detection of the abnormal reactions by collecting the data, analyze the big data, and giving the hints to predict the future. So having the digital twin is just like having the plant virtual twin, and you can do many things with the digital twin virtually without any risks to have something happen in reality, because you are working with the virtual.
Yeah,
right?
That's one of the objectives, yes, sir.
Right. So and at the end, I think we can conclude that implementing the digital twin, it means that we have to put the digital twin as our infrastructure for the operation, right?
Thanks for summarizing.
Okay, I think that's the really interesting presentation, and we will start with the second presentation, and after the third presentation later, we will have the discussion and the Q&A. All right, to complete the presentation by Pak Hiroyuki from the Dassault, we will continue with the presentation from AVEVA, by Pak Segaf Husein. Pak Segaf is a digital transformation professional with more than 10 years experiences and strong track record of exploiting the power of digitalization. Wow, the digitalization to tackle the business challenges throughout the full asset life cycle, from creation, engineering, procurement, and construction or a project to operation and maintenance. With the area expertise in the information management, data management, class library, engineering software, document management, construction management, EDMS, project management, database management, application deployment, and asset performance management. Pak Segaf Husein has a bachelor in computer from the ITS 10 November Institute of Technology and master in information system management by Business University. And Pak Segaf will present us the digital twin, accelerate the digital transformation for upstream oil and gas from design to operation. I think we will start the presentation, and I would let Pak Segaf to start the presentation, please.
Okay, thank you, Pak Edwin. So I'm sharing my screen. Please let me know if you can see my screen. Okay. Okay, so please let me know.
No screen is coming in, Pak Segaf.
Pak Edwin and everyone, sorry, I am having a technical problem with Zoom, so I'm trying to share my screen. Let me know if you can see my screen.
Unfortunately, the screen is not there yet, Pak Segaf.
Okay, so I think it should be on now. Can you see it now?
Yeah, I see the logo of the Windows.
Windows logo.
Okay, now it's there, so you can start.
Okay, so my presentation is on now. Thank you, Pak Edwin, for the introduction. So first of all, I would like to say thank you for Iafmi for inviting us, AVEVA, to be part of this good event today, good webinar where we can share and learn from each other. So it's an honor for me to be able to share this forum with you all. So as Pak Edwin already introduced me, my name is Husein. I'm currently a consultant for AVEVA Asset Performance Management Portfolio, with covering Southeast Asia market with focus in Indonesia. When we talk to the project team, they will say that their focus is on delivering the project on time, on schedule, and on budget. While when we talk to the operation and maintenance team, they will have a different focus, which is to run the asset on the most safely and reliably manner as much as possible. So because of these organizations were run in silos, we often find that there is a missing link between them. And this missing link can sometimes create a bigger problem that may have an impact to the business. So my topic of presentation today is about digital twin and how we can use digital twin to accelerate the digital transformation in our industry, upstream oil and gas, and also to bridge the gap between the design and operation stage. So I would like to start my presentation with a simple definition. Digital twin. What is digital twin? So the simple definition of a digital twin is a digital replica of our physical asset. So our physical twin, physical asset, we can refer as a physical twin. So in a digital twin, we have process and system that can be used for various purposes. So by using digital twin allows us to design and operate the physical twin on the most effective and efficient way. Okay. We have to understand that technology is a means to achieve certain end for business. when we look into some technology that enable us to have this digital twin, each of technology brings a unique value to the business. So when we talk, for example, about AR or XR, it gives us an enhanced visualization and experience. It likes bringing the gaming experience into our working life. When we talk about big data analytics, it enables us to abstract knowledge from a large chunk of data. And for another example is cloud. Cloud gives us more flexibility on how we want to access our information. So what is the main objective of all this technology? Why we want to introduce this to our business? So the main objective is to create a digital disruption. So we expect a digital technology to bring a transformational impact to our business. Actually, in Indonesia, I think we have the best example of a digital transformation, a digital disruption in the last maybe around 5 to 10 years, with the Gojek story. I think Gojek has transformed the life of most Indonesian. I believe everyone in this forum have Gojek installed in their smartphone. So Gojek has transformed our life from the way we move from one place to another, or even ordering our food, or even asking for other service like, in Gojek we have Go Massage, my favorite, of course, and then we have a service for beauty salon, and also even asking someone to clean our house. Now Gojek, they have more than 100 million downloads with more than 150 million transactions weekly on average. In 2018, Gojek was listed number 17 in the important list of 50 companies that changed the world. So it's a big impact coming from a company started in Indonesia. So by using a digital twin, we expect to be able to bring a similar level of disruption to our. Now the questions. Why? Why is this important? Why all this digital technology is gaining pace now? Why is this becoming important? To answer that question, I would like to bring some interesting statistic here. First is that we found that by the end of 2020, there are already 31 billion of IoT devices globally installed. Okay, so that is a big number. Another thing is that 87% of manufacturing enterprise now report of using cloud throughout their organizations. Another interesting fact is that 85% of industry leader is now looking into AI and digital transformation as their priority in the next 3 years. And I believe this number is only at a starting point, and it will only continue to increase. So McKinsey, in one of their reports, state that companies further along the digital journey are realizing 7+% more revenue growth compared to their peer. So 7+% more revenue compared to those who are behind on the digital journey. We understand that the COVID-19 already bring more focus on digital acceleration. So the industry now is moving faster into the digital world. So COVID-19 resulted in 2 years digital transformation progress being done in 2 months. And we expect this acceleration to continue on. So it won't stop here. So another interesting statistic that I want to highlight here is that 82% of IT leaders now saying that they have accelerated the adoption of cloud as a direct response to the COVID-19. Okay. And 65% of decision makers now put operational resilience as the top 3 priority of their organizations. So, and then from Gartner report, they summarize this very well. What is the difference between the digital transformation prior to the COVID and during the COVID situation? And the answer is pace of adoption. Now we are moving faster into the digital world. Here I have another quote from Gartner, which I think sums it really well. So executives used to think that building a highly resilient network was simply unaffordable, but the COVID-19 crisis has made the ability to respond to change an urgent priority. So before this, a lot of our industry leaders thinking that digital transformation is just an option. It's something expensive, it's an option, it's good to have. But now due to the COVID situation, it's switching. So digital transformation is now becoming a necessity. It's becoming a must. Those who are left behind will be left behind in the industry as well. So we have to change. Okay. That is, so far I only talk about the industry as a general situation right now. Yeah. Now I want to look into more detail into our industry, the energy industry, upstream oil and gas business as well. So when we look into the progress through digitalization curve, we found the fact that, okay, IT and finance is the leader. So there is no surprise there. They are the leader of a digitalization. And then we also have industry like telecom and retail following them. But when we look into our industry, you see energy industry is way behind compared to the other industry. We are even behind marine industry. So maybe this tells us something that as an industry, we tend to be more conservative, but I think this is something that we need to acknowledge, and hopefully we can take action upon as soon as possible. Okay, when I start my presentation, I already mentioned a little bit about that company often split their organization based on the production facility life cycle. So usually in owner-operator organization, we will have like project engineering team, project engineering organizations, and also operation and maintenance organizations. Since this organization were run independently or in silo, we also find that the progress of the digital transformation for each line of business often not aligned most of the time. So over here in AVEVA, we identify 5 levels of digital maturity for an organization. If you look at the left side, this one focusing on the digital maturity for the engineering, procurement, and construction or the project team organizations. And on the right side is focusing more on the operation and maintenance organization. Okay, so the 5 levels of a digital maturity. Level 1 is completely silo, means almost no standardization or sharing of information and process tools. Everything is done manually. Okay. Level 2, we have top management acknowledgement. We have top management recognition, and we start doing some pilot project to mitigate the situation. Level 3, we already start implementing trusted information and standardized process. And then in level 4, we already have cross-organization working together on the same platform. And level 5 is when the enterprise, we already be the best in class, and we can say that digital technology already bring a competitive advantage for us. So the best transformational result for an organization can be achieved when we can align these 2 major cycles from design cycles, project cycles, and operation life cycles. So Pak Edwin, if you can help me next, I would like to run the polling to understand the profile of our audience today. So,
okay, good. And can also please just back to the previous presentation, I think, just to understand the, yeah, thank you. This is it.
The audience, please.
All right, the audience can just again click on the number 1 and number 2 questions with the related answers that fit to you. There are several questions, so this is not only 2 questions, but there are 4 questions in overall. So please make sure to fill in those 4. So then after that, you can just submit the poll.
Okay. I think we have enough answer to move on, Pak Edwin. So I think some today is coming from project engineering. I'm surprised no one is from the operation and maintenance team. And then I think most still saying that the organization is run in silo. Some have recognition and planning already from the top management. We have a very optimistic response when saying we have optimized, best in class. That it's good, very good. And then it's a very interesting answer all over. So this tells us that often we need to be able to identify our digital maturity. Yeah? So I would like to continue with my presentation. Now we know that our industry is still way behind compared to the industry on the digital initiative. Yeah? So let's look into the business imperative in our industry. So during the engineering or project life cycle, we often find a challenge that capital projects are over budget by 40% and delayed by more than 20 months on average. This is a report by Independent Project Analysis Group. So what we want to achieve by implementing a digital twin. So what we expect is, of course, we want to have a lower total cost, time, and risk in the capital project. Yeah? Moving on to the operation stage, what is the typical challenge in the current situation with the operation stage is that, okay, we now have a rising global demand. Again, we also have a highly volatile price on oil. We even have a below zero price last time. And also we have a more strict regulation regarding environment. I think that is that three challenge is really the big challenge right now. So what we expect is we want to be able to use digital twin to plan and operate to maximize our profit within the operating constraint and also the regulations. Moving on to the maintenance activity, what is the typical challenge we find during this maintenance activity is that this is a report by ARC Advisory Group that they find unscheduled downtime result in $20 billion in annual production loss in the process industry. So that is big money, right? And overall, of course, we want to increase the longevity and performance of asset while ensuring safe and reliable environment for our worker. And overall, by implementing a technology, of course, we want to have agility and enable collaborations. Okay, that is a perspective from business. Now, another perspective that we need to consider when we are embarking on this digital transformation journey is the worker perspective, because our worker is the backbone of our business. Okay, so what is our worker expect from a digital twin? So we formulated at least 4 things. First is the experience. Why? Because our worker now already using the smartphone, smart device, smartwatch, smart TV. So they expect to have a similar experience on their working daily activity. Second is about flexibility. Of course, with having a digital technology, they expect for us, for them to have more flexibility on how they execute their tasks. Yeah? Next, number 3 is about collaboration. Digital twin have to enable collaboration across multiple teams because we need to collaborate. Our worker need to collaborate with their peer or their colleagues. And then last thing is about intelligence. Fourth is about intelligence. So they expect the digital twin to give them some insight, some intelligence to help them to come with the right decision in the right time. So digital twin as a decision support system. Now understanding that, we now can see into more detail of a digital twin. What comprise of a digital twin? So the first component of a digital twin is, of course, data. Data is the first component. This in a digital twin, this data can come from engineering data, engineering document, engineering data, your PNID and other documents. It can also come from your operation system and maintenance system, from enterprise asset management, or your DCIS, or other data source in our industry. So that is the first component. The second component is about models. Models basically tells us 3 things. One, it tells us the past behavior of our asset. Second, it represents the real-time monitoring of the current operations. And by using models, we can help to have a prediction of what will happening next time. So that's why now we have this trend of a predictive maintenance emerging in our business. And then the third one is, of course, visualization. Visualization is a means for us to interact with the digital twin. So this is what we see. So we can access the digital twin through human-machine interface, or through a mobility, or using AR/VR technology. These 3 together working side by side, then it becomes an integrated digital twin. Yeah? Okay. And next is, again, I already talked about the importance of our worker. Then what we want is our digital twin to empower the worker so they can become a connected worker by enabling a collaboration, accelerate the learning process, and provide them with guidance for decision-making process. So in AVEVA, we believe that digital twin is a foundation to transform our work to enable the connected worker. Connected worker is a human-first approach to digital transformation to empower the worker to become an agent of change. By giving the right access to information and knowledge and insight to our worker, we believe our industry will thrive more. This is when the human experience meets with digital technology. Okay. In AVEVA, we provide a 360 view of a digital twin, starting from engineering design, early life cycle engineering design, moving to construction, handover, and also operation maintenance. We connect people and assets with technology that predicts outcomes and provide guidance, giving every team member visibility to the right information to make precise decisions. So we split our digital portfolio into three major portfolio. One is the engineering, second is operations, and then the third is performance intelligence. So over here, you can see how AVEVA incorporate all this technology that I have mentioned before, like AI, cloud, big data, IoT, and other technology into the engineering and operation lifecycle to drive sustainable value and to enable the connected worker. So, and by doing this, now we can use a digital twin to bridge the missing link between the engineering and the operation team. So when we talk with the engineering, so we talk about design, engineering, build, construction, commissioning up to as-built program. Yeah? And then when we talk to the operation and maintenance team, we are talking about process analysis, predictive maintenance, asset reliability, and all those stuff. So by having one continuous digital twin covering both life cycle, we will have one single data environment to enable smooth handover from engineering to operation. We will have a standardized view of document, data, and information, and transforming them into easy to consume knowledge. So we understand also that our connected worker need to be able to access the correct information at the right time when making decisions. And trusted information has at least 5 qualities. It needs to have authority. It needs to have authenticity, reliability, integrity, and of course, it should be usable. It needs to have a usability. And over here is when you can see our portfolio into more detail from conceptual design, engineering design, handover, moving to operation and maintenance. And we provide solution on each cycle of the production facility life cycle. Yeah.
Segaf, excuse me, so you have 2 minutes left for the presentation.
Okay. And this digital twin is to empower the connected worker, of course, to help them working on their daily activity. So we have some success story with Shell where they implement our digital twin during the project life cycle by having a single environment between Shell and their EPC on the cloud. And then we have another success story with SCG, where they implement the digital reliability platform for their operation from upstream Thailand. Another is a success story that where we have with Abu Dhabi National Oil Company, ADNOC, where they implement this 50-meter panorama command center to monitor and control and optimize the performance of the asset. So I just go with you. Now I would like to end my presentation with key takeaways, what we learned, what I have presented today. So the first takeaway is, of course, that we understand now COVID-19 pandemic has bring new focus on digital transformation acceleration. We have to adapt with new normal. Don't be left behind, because we can no longer be left behind as an industry. Second is that for a transformational value from a digital twins, we need to be able to bridge the asset lifecycle from design to operation. So the digital twin need to be able to bridge these two major life cycles. And the third one is that last but not least, digital twin, our main worker, they are backbone to our business. Okay, so thank you for listening. Don't hesitate to contact us. You can send me email, or if you have further question, or you can also access our website to learn more about our portfolio. So AVEVA, we just completed a transaction to bring the best-in-class data management solution platform from Osisoft as part of the AVEVA family. So I believe a lot of you know Osisoft. So now Osisoft is also part of AVEVA family. And to end this, I believe working together, the industry, the expert, we can only achieve so much better. Okay, thank you. That's the end of my presentation. So Pak Edwin, I hope I did not take too much time. Hopefully it's still.
Thank you, Pak Segaf. You always present something very interesting, and today as well. Thank you again. With the topic of accelerating the digital transformation for the upstream oil and gas from design to operation, you really just presented very well. And I think we can conclude that yes, digital twin, digital platform, this is bridging or transforming from project to operation by having the digital twin, by having the virtual plant or virtual facility in which from project transform to the operation, and operation can really operate it virtually, so that the operation team can anticipate any expected or unexpected things, so then they can mitigate the and anticipate the unexpected things, so the decision can be made accurately.
Yes.
The other thing that is very interesting is that I just quite surprised that the in energy industry is the lowest, on the lowest part, yeah, on your curve, showing that the digital transformation maturity is just there. I think that's really hit me, in fact, you know.
Yeah, but I think we are now starting to acknowledge that we need to transform. So it's good. A lot of organizations already have this recognition from the top management. So,
okay.
For example, your organization, Medco, I know very well. It's a massive digital transformation. And also Pertamina in their 2019 or 2020 report, they say that they want to use digital technology to further advance their business. So now we start getting more recognition, but we are still a bit behind compared to the other industry.
Okay, I think we have to make it faster then. The other thing is something that is also very interesting, in addition to your takeaway or your conclusion previously, is that the you mentioned about the experience, flexibility, collaborations, and intelligence. In fact, I just want to see more on your presentation about this one, how in fact those are really interfaced and interconnected between experience, flexibility, collaboration, and intelligence. I was thinking that in fact that is the character of the digital platform or digital twin itself.
Yes.
We will discuss about that later. Just be patient, Pak Segaf, yeah. Just keep your energy for our discussion later, because we still have the third speaker, another distinguished speaker from GE Digital, which is Pak Abdullah. Thank you for your time just to also attend this webinar and being the speaker for Iafmi. Pak Abdullah is the APM Oil and Gas Pre-Sale Solution Architect for the GE Digital. Abdullah has 15 years experience in a multi-regional environment working in the APM, digital industry, energy, oil and gas, with exposure and interaction with all client roles, including CXO, business partners and channels, IT architects, and technical experts. In his role, he leads the technical selling and demonstration of GE solution, GE digital solution, I think. Solution designed to deliver on client expectations and scoping of complex client deliverables. Abdullah also has experience in leading remote monitoring team. This is very interesting. To deliver positive impact on customer plant performance, provide technical management and field troubleshooting on machines, rotor dynamics, field balancing, attending commissioning of gas turbines, and provide regional training for the machinery diagnostic services. While talking about the remote monitoring team, that is something that also become a challenge and also opportunity on the on this new era in which we are always facing remotely, virtually, so that the leadership, the teamwork becomes something that need to be redefined for the kind of organization and interaction. I think you can share this one as well, I hope. Abdullah has a background master in design and simulation of mechanical systems from Liverpool, John Moores University in the UK, and a Bachelor of Mechanical Engineering also from the UK. So the topic that will be presented by Abdullah is the need for performance twins, predict, diagnose, and forecast. So Abdullah, your screen is yours. You can start for the presentation, please.
All right. Please let me know when you can see my screen.
Not, yeah, okay. You start with the, yeah, all right, now, available already.
You can see it?
Yes, we can see it now.
All right, well, thank you for having me. Good morning, good afternoon, good evening, everyone. My name is Abdullah. I'm gonna talk about the need for performance twins, predicting, diagnosing, and forecasting. So let me start first with GE Digital and what is our mission. So from our perspective, bringing simplicity, speed, and scale is of utmost value to our customers. The digital transformation is a long journey, which we understand, and so we need to accelerate and we need to provide boundaries to it in order to provide our customers with value, reduce the time to value, and make them realize that value, which is in many cases or in many projects are not really seen. So today we have in our digital twin blueprints, we have more than 300 existing blueprints or existing models, if I can say, just to make it easier. And we do exist in several oil and gas customers, upstream, downstreams, and towards the end of my presentation, I'm going to talk about one of our success stories. So let me start with differentiating what types of digital twins are there. So it can be, the digital twin can exist in projects, it can exist in performance, and it can exist in the plan, the deconstruction, and the recycling. And from GE's perspective or from GE's focus, our focus is mostly on the equipments, where we look at the operation and maintenance. So that is where our expertise is, and that's where I'm going to focus on in my presentation today. What we can see here right now is the PF curve, as it is known, representing the performance of the equipment as it degrades towards a functional failure, which is somewhere in the green zone. And that's when an equipment can no longer do what it's supposed to do, the functional of that equipment. So conventional monitoring solutions typically operate in the orange zone. That's basically where you can see lots of alarms and events being triggered. And the green zone, of course, you have the trip factors, you have the OEM set points, etc. And the predictive analytics really works at a very early signs, or at a very early stage, which is around the gray area. As soon as something starts to deteriorate or something starts to happen in your equipment, that's when you will be notified. And that will be way ahead of any alarm value normally. So this can be days, weeks, or even months ahead of the failure. And the reason, of course, I mean, why it can be from days to months is depending on the failure mode and what is progressing. So some failures, they do take place really quick, while others, they take considerably longer time. Now, when you get to know about the failure way ahead, now in the oil and gas industry, it's very difficult to stop an equipment and schedule a maintenance because it's generating lots of money, and that is well understood. However, when you get to know about the equipment failure very early in the game, you can actually plan for the shutdown. You can um, have your spare parts ready, the crew to do the maintenance ready. You're fully aware about the deterioration way ahead, that you have already done lots of investigation and deep dive diagnostics. So when the machine is down, you can minimize the downtime, you can have everything in place, and you can minimize the waste. Another important factor, which is again from monitoring customers' equipments, when you're looking at lots of equipments and you have limited resources, typically you will schedule um, the monitoring of these equipments, and you will be spending hours and hours just searching for abnormalities. And this abnormality, you may pick it and you may not as a human being. If we look at a human being that is covering, let's say, 100 critical assets in a plant, and every asset can have anything between 100 to 500 tags. If we look at a turbine, for example, a turbine can have 500 tags if it is well instrumented. Now, correlating all these tags together to understand the behavior of the machine and to understand if it is deteriorating or not is very tricky, and it's very time consuming, especially with the challenges of the time constraint and the challenge of lots of reactive activities or failures taking place in the plant. So this is where the solution, the digital twin, will actually help in looking at all these tags, understanding their behavior, and understanding when they start to misbehave or when a malfunction starts to develop. So you can be notified way ahead, and you can be aware about it. And as I said, when you are aware about it, you can actually start the investigation, the deep dive diagnostics. You can schedule the service, the spare parts, calling an OEM, third party, etc. So fundamentally, when you start relying on digital twin solutions, you will shift from monitoring the assets every single day, searching for abnormality, to waiting until you have an abnormality picked for you by the solution, and then you spend your time in doing the analysis. So less time randomly checking for abnormality, and that time to be utilized in analysis, diagnostics, planning, etc. And this can significantly improve the value for customers. And as I will show, one of the great results, that you can actually reduce or even eliminate unplanned events completely. And that is not just a theoretical talk, that is practical, as I will demonstrate later. So in order to have such value, there are three components of the digital twin: to predict, diagnose, and forecast. And I will elaborate each one of them. Now, of course, the time to value or the scalability is an important part. And this is where personally I have seen lots of digital transformation projects fail because they are not scalable. You have an engine, or you have a technique, or you have a tool, but it's not easy to scale it. And one of the reason is not having something upfront that is ready for deployment, and the need for constructing something from scratch, which can vary completely, which can have human errors, etc. And this is where the blueprint, as we call it, or the model that we have built, it's pre-configured, and it's for a unique asset. It's not something like you can just randomly use it everywhere. That pre-configured blueprint basically allows the scalability, and it allows eliminating human errors. So you don't have to create things from scratch, but on contrary, you have decent, ready, pre-configured failure modes, diagnostics related to these failure modes, etc. And it's applicable for a specific equipment that you can just go ahead and deploy. Moving on to the value of the performance digital twins. So, of course, what we are trying to do is to manage risk, and that is our ultimate goal. And like I said, reaching the status of unplanned events is really of a great value. But then we need to think about improving the availability and reliability. And that can be also tricky because we can be overspending, we can be underspending. So how can we optimize the cost for the availability, or spending more on improving the availability and reliability? So this is where the balance is very much required, and the cost optimization is required. And this is again where the digital twin can add value. Now, before I move on with the digital twin, what do we mean by digital twin? So the way we like to think about this, about the digital twin, is that this is a software representation of a physical asset, system, or a process designed to detect, prevent, predict, and optimize throughout. So this is how, from GE, this is how we view it, this is how we look at it. Now, as I said, there can be different applications for digital twin. We are at GE focusing on equipments, and this is basically how we look at the digital twin. So consider if you have a gas turbine at the heart of your plant. Now, in principle, this can be a mud pump, it can be a jet engine, it can be compressor, whatever the asset is. Now, under the gas turbine, there are lots of tags, lots of instrumentation, and that equipment by itself costs millions to build, and it costs millions to fix, operate, and maintain. And of course, this is significant when that equipment, turbine it is, or any other equipment, when it is down and it is not generating value for you. So imagine if all gas turbines can predict their own future. And imagine if all these gas turbines can talk from one site to another, and they can share the information, and they can share certain patterns in the behavior and eliminate future failures. This is ultimately where we are heading with the digital twin, and where the industry is going through. Now, what makes a digital twin? Now, there are different aspects of the digital twin, starting with the subject matter expertise, which is very essential, whether it's a software or whether it's any solution. Subject matter experts is basically where all the knowledge is being transferred, where all the failure modes and the degradation mechanism are built. And then that is configured, of course, with the help of instrumentation, as we have been talking today. The data is very important in order for us to predict and in order for us to have proper analysis. So without it, we cannot really have deep diagnostics, and we cannot actually improve the condition. So let's take an example here of a traditional onshore drill rig. One of the critical pieces in such a plant is the mud pumps, which circulates the drilling fluid. Now, what makes up the digital twin for the digital twin blueprint for a mud pump? Now, and for the mud pump, we know we have like 11 failure modes already built in, and we have 36 different causes for these failure modes to occur. So the first component of the digital twin blueprint is the FEMIA in the asset performance management. So in other words, it has already knowledge or content built inside it. So it is not really waiting to observe the behavior of the equipment and then learn from there, but there are already knowledge built in that blueprint. Now, the next element is the asset strategy for mud pumps, which includes an optimized set of preventive maintenance actions, such as lubrication intervals, visual inspection, torque checks, etc. Now, these analytics enable the operator to monitor and provide early detection for over 36 different conditions on a mud pump. Now, with the asset strategy, excuse me. Now, with the asset strategy, the blueprint are the mechanism to monitor overall health of the mud pump and taking into consideration the collective set of data coming off and being collected on the mud pump. This gives the ability to proactively respond as emerging threats happen, and also this increases or measures the ROI and the overall pump performance. If I move on quickly, like I've been saying, in our catalog today, we have over 300 existing digital twin blueprints, and these are covering a wide range of assets. Now, these can vary from rotating to static. It can vary from the industry. So airline companies can have the solution, and some of them do, like Air France, for example, or KLM. And it can also be applicable to a mud pump application. It can be like typical oil and gas equipment, and it can be also in the power industry, etc. So it is not really fixed to one industry. It's not really fixed to one type of asset. If I go to, so this is, the blueprint is basically the fundamental. This is where the content or the knowledge is built. The second part of the solution is the prediction part. So the solution, the digital twin, will provide the actual data that is coming versus the expected data. So what the solution really understood from that equipment's behavior and how the actual data is different from the expected data. And depending on that difference between the actual and the expected, that's when the user will be notified of developing or impending failures that just starting to happen. So as you can imagine, this is going to be very small in value because we're talking about very small difference between the actual and the expected data. And the unique thing about this is that there is no alarm, like to be set for every tag. As I mentioned, in a case of a turbine, you can have like 500 tags. To go and set a software alarm or a set points, what is acceptable limits or bandwidth for every sensor is really time consuming, and it is really not up to speed with the digital twin that we're talking about. So the dynamic band here, sorry, the band here for every tag is dynamic, and that's what the solution will understand, and that what has been configured for that specific asset. Of course, GE is a manufacturer of equipments, and we understand how they operate. So accordingly, we have built what you can call our best practice. The second part, or the third part, sorry, is the diagnostics. So in the diagnostics, of course, you are expected as a user to receive first what is the priority of that advisory or of that alert. So should I immediately jump and look at it, or can I wait? Should I look at something else and come to this in due time, etc.? So the diagnostics will have a priority number ranging from priority 5, which is least, to priority 1, which is top priority that needs to be attended as soon as possible. Of course, this will come with a type or explanation of what has changed, what are the observations, and what are what is the issue about. The last part of the solution is the forecasting. So if I'm an operator and I receive again a priority 1 or priority 2 or any priority advisory, then what? How much time do I have left? can I handle this? I mean, do I have like 10 days? Do I have 1 hour? Do I have 1 year? So that is also a very important part. And the forecasting is really to help plants, excuse me, is really to help operators optimize their plant. So the forecasting tool, now many vendors, they do have it as a linear curve for every tag. From our side, we have a regression modeling. So it can be done in a linear way, it can be done in a non-linear way, depending on the priority of the user. And this comes with a confidence factor of over 90%. So the time to action is really the time that you have for the equipment in general, for the equipment as a whole, until it reaches the OEM hardware set points. And that is key in order, again, to optimize the time, to optimize the spare part. And in some cases, you might be aware about an issue, but you still can't, for many reasons, can't shut down the machine, whether the spare parts is not there or you have a planned shutdown coming soon, etc. So with the forecasting tool, you can estimate on the time that you have until you will have a forced shutdown, and that can also be of a significant value. Now, our performance digital twin have actually existed for quite a while, and we have been able to deliver over $1.6 billion of values. This is reported by customers, not our estimation, but it's coming from customers, from different industries, from different type of losses avoided. This can be production, mechanical, electrical. So any kind of losses is really of a significant value. And this is what have been reported, as I said. Now, the digital twin is very important to integrate it with the work processes of the asset performance management. And that really is very key. When you have a digital twin advisory, how do you connect it with everything else in your plant? This is basically the value. So starting with a strategy, the strategy, I mean, it's a continuous loop, but looking at it from strategy first. So the strategy is basically where you define which assets are very critical to your operation, which assets require the most sophisticated systems to monitor, which assets are okay to keep them to run to failure, and you don't need to invest in them. When to invest in that asset and when just to keep it to run to failure, or when to replace it. So from my perspective, strategy is a good point to start. And then you put the strategy into operations and maintenance, and you monitor how things are progressing and how your strategy is developing. Then you have the analytics and action, and that also feeds into the operation and maintenance, and how that analytics and action have controlled or mitigated the risk that you have in the plant. So it's all really a full cycle, and it has so many components. But connecting all these components together, whether it's from the asset strategy, whether it's from the mechanical integrity, whether it's from the inspection, from the rounds, from everything you have in the plant, connecting all elements together is what make a success for the digital twin. Looking at a point solution can always be useful, but within certain limits. So it is not really gonna increase the value or the return on investment as when you have an enterprise solution that you have different softwares or different solutions talk to each other and feed each other for a continuous improvement. All right, so moving quickly to the case study, or one of our success stories, which is coming from Total Exploration and Production. This is from Total Upstream. So Total Upstream, they do have operation across all continents. They have significantly big operation onshore and offshore. And they are producing more than 3 million barrels per day, which is a large number. Now, they are second in the LNG, with a plan to be the first LNG producer in the coming years. So Total, they have been operating these platforms or these affiliates with big challenges coming in their main assets, in their critical assets, and they've had lots of failures. And what Total wanted to do back in 2010, they wanted to find a solution that can help them in eliminating or controlling these failures on their critical equipment. Basically, they have deployed our digital twin back in 2010, and they went through the journey of shifting from reactive to proactive to predictive. And since 2013 until today, Total has been able to have 0 unplanned events, and they have been running the solution and the plants by themselves. So that is quite remarkable from my perspective, considering the large operations that they have and the scattered operation, if I can say, across different countries, different continents, different time zones, different language, but they all speak the same language with one unified digital twin that is deployed across all the plants. And with this case, I am gonna stop right here, and thank you for listening, and it was a pleasure to be your presenter.
Okay, Pak Abdullah, thank you very much. I think this is really a good closure for the presentation, because you really conclude the whole digital twin concept and the digital twin initiative by your interesting presentation. There are 2 things that I would conclude from your presentation. I would say first is the value of the performance of the digital twin. You are mentioning about the managing the risk, reducing the cost, then improve the availability. So I think this is really things that is very key from your presentation, and also concluding the whole presentation from the beginning. And second is you are mentioning about the function or the objective or the of the digital twin is really to detect, prevent, predict, optimize through the real analytic and action. So those are the conclusion that I would add to your conclusion for your presentation. And I think we would like to thank to you for the closure of the presentation, and we will start to have the panel discussion and answering some questions that come up through the chat. So I think we can start with the discussion. Yeah, there are some questions that come up with all the initiatives in the in this digital twin. First, one thing that I come up really from the beginning was that if we are going to implement this digital twin, while the oil and gas is really an old industry, basically. In Indonesia, we have hundreds of platforms. I think there are more than 600 or 700 platforms with the old stage of the platforms, for example. Now, my question is, if we are talking about the brownfield and having the plan to implement the digital twin from the brownfield for the operations, involving the hundreds and thousands of documents, data, and I believe thousands of control system equipments, instruments, electrical, and everything. The question now is how you can capture all the data, the documents to the digital twin. Yeah, I think this question will be for all the 3 of you. But before that, I would like all the speakers to turn on your video so I can see your expression when having the questions. I can see Pak Abdullah is just smiling with the question, I know. Perhaps Pak Segaf and Pak Hiroyuki, can you just turn on your video, or you turn on already?
I already turn on my video.
All right. Okay, Pak Segaf, you turn on already. I'm waiting for Pak Hiroyuki. I'm trying to check. All right, I think we can start to discuss with the first question. I think you can start, Segaf, with you on this one.
Start with me. So yeah, so I think your questions really tie back with that graph, right? So we are a bit compared to the other industry on the digitalization progress. And then talking about, we need to understand what is our challenge, and then we need to have priority on which we want to address the challenge first. Okay. So when we talk about digital twin, again, the first component, as I said, is always data. So for all asset, the first thing then we need to be able to consolidate the information. So you are talking about digitization process. So we need to digitize the as-is information. So we can do this with a lot of strategies. So for example, laser scanning now is one of the most common technology being used to digitize the old platform to capture the existing as-is condition of the old platform, and then we can build digital 3D models from the laser scan. And then we can digitize the engineering document by running the as-built program, or we can digitize it simply by giving it a context with other information that we have on the asset. That is from an engineering information perspective. What about the operation data? So operation data, usually we have sensors, and then we have DCS, we have PLC. Now we have this historian system that capture all this data. So engineering data, operation data in silo is good in a way because it can give us some insight. But if we want to explore and to get more information, get more knowledge, then we need to be able to integrate this into a single source of truth, giving a context between operation and also engineering data. Again, it's bridging these two worlds is the challenge now.
Okay, thank you. Then, if that's the concept, I believe that that really the technology is available already for the laser scanning of the facilities, the platforms, or also it is big facilities. Hiroyuki, do you have any experience of having the scanning the plant facilities and scanning use of documents and data for this developing the digital twin?
Herve, honestly, I want to be honest about these topics. Okay, so that's true that we have, the technology like laser scanning and the lots of the technology to capture the digital twin. But reality is not such simple. You are raising the really difficult question. Okay, so if we really go to the customer, okay, so it's not just a 3D. But I know that if you go to the brownfield customer, they don't even manage the master functional location list and the master equipment list, right? So the first step is that we have to sort out all these the mess of the data. This is very time consuming. So you can imagine that I have the real experience in the nuclear power plant, but if you imagine that's a boiled water reactor, that they manages almost the hundreds, thousands of the tags. So you can imagine how long it takes. Anyway that we have to do it by the human, and then the document is because of the historical the contract with EPC company. The document is delivered with the paper. It's not such a simple, that we have to change each pieces of the old legacy. So, honestly, I agree, we have a laser scanning technology, we have, the OCR technology and so on, but yeah, we don't have, really the silver bullet. We don't have a silver bullet. For example, the very often the owner operator doesn't have the digital data, but if you really talk to the EPC companies, they have it. Yeah. So one by one, you have to check what is the status, and then what could be the possible. So yeah, honestly, it's not such a simple. Technology cannot resolve this.
All right.
That's the point.
Okay, thank you. What about Abdullah? What's your opinion on this? Just talking about the brownfield facilities.
Well, I do share some of what the other gentlemen have presented, which is the data quality has been always an issue, whether the customer is a top mature customer or really a startup. It's in most of the cases the same. You will have lots of gaps. You'll have lots of issues in the quality, missing data, and lots of information. So this is definitely a challenge in many of the cases. But I have to say also, some digital twin solutions, they can have also some data cleansing capability, which can improve a little bit. I'm not saying it will eliminate. Plus, if you have the right resources who will be engaged and who will, they're going to do like this out, because technically good quality historical data is not going to be there ever. So it's either you just wait where you are, hoping for one day you will have good quality as a customer, or you can just start with what you have and put the right solution in place and have the right resources who will continue to clean in addition to the cleansing capability of the solution. But even you need human beings to continuously look at the data, do some cleansing, do some filtration, and have in the right data. That is the only way forward. So you might start with 50% quality data, 70%, whatever it is, but it's better than not doing anything and just waiting for one day to have good data.
I fully agree.
But you mentioned that you can start with whatever you have, right? It seems like there are two things. First is the what you have in terms of data, what data that you have. Next is perhaps we can, or you can start with the equipment that has the most significant cost for the maintenance, for example, or the operation, in terms of operation. Now, what about you, Pak Segaf, in doing this one? So you can start with the data that available. You also start with some equipments that you think that it is the most on the operation cost or the impact.
Yeah, but so in the operation and maintenance state, often we run what we call a risk-based maintenance approach. So we analyze and we assess the criticality of equipment. Then we will have a list of most critical equipment. And then for a solution like a predictive maintenance, is usually we deploy this kind of solution to help us to mitigate the problem with these critical equipment. So again, we need to start at some point, and then we need to understand the challenge as an organization. What we need to understand what we have, and then we have an end goal, and then we build our roadmap based on that. So assess the current situations, understanding our challenge, setting up a goal at the end, what we want to achieve, and then we keep doing continuous activity to achieve our end goals. So and then some organizations, maybe a major oil and gas company, use think that on the operation and maintenance stage for the old asset, the highly critical equipments, those who that cannot be died, or that the unplanned it can cause an unplanned shutdown. Then we start implementing the solution for predictive maintenance, or even now we have a more solution, more advanced solution like a prescriptive maintenance. So start somewhere, review where you are, and then keep trying to be the best in class.
Okay. Okay, I think that that's also quite answering the question of if we start everything in once from the beginning. I mean for the brownfield, yeah, all the equipment to be digital twin. I think we are creating or planning something to fail. But if we start one by one, as you mentioned, Pak Segaf, start with the most risky equipment or operation system, and start with that, and then develop and continue. I think you are building a success for the digital transformation, I believe. I think you agree with that, right? Okay, now, it seems like if we start with the brownfield, it is quite difficult, but if you start with the project, yeah, as you mentioned, you start with the design to operation, you start with the design, start from project. what do you think? If we start with the project, what is the cost for creating from the start from the project? Is it cheaper, or is it more efficient start from the project, or start from the brownfield to develop the digital twin? I think I will start with Abdullah for this question.
So, talking about cost can be a little bit tricky, to be honest with you, because starting too early does not mean that you're going to have, good data. Again, you might have lots of missing data and still not available. So, in terms of cost and effort, I would say it can be either way. From my side, I cannot really tell. But what really matters, if you have a green field, is that you will have very limited data initially, which can be also a challenge to build a digital twin, and just to understand the behavior of the machine, how it's been behaving. So if I talk specifically about GE digital twin, like we don't build failure modes, for example, in the digital twin based on customers' data. It's already pre-built. However, we want to understand how that machine has been behaving in normal conditions. And during commissioning stage, the machine doesn't really operate in its normal operating conditions. So again, it may require some human intervention and human support. So from cost perspective, to be very honest with you, it's very tricky. It can be the same from my perspective. I'm not sure about the other gentlemen, what they feel.
Okay, what do you think about your Hiroyuki?
So, my observation, of course, we start from the greenfield, it should be much cheaper, or, we can expect out, the higher quality. Okay, so, let me tell you, my experience, I particularly, has a lot of the experience in the nuclear industry in Japan. Okay, so of course, I do, the oil and gas industry as well, but I have a lot of the experience in the Japanese nuclear industry. But, my observation is, even the owner operator itself, themselves, they run a lot these days. Okay, and then they structure. Okay, so how do we manage the failure mode, and how do we manage the deterioration? So they have a lot of idea. But when they built the brownfield the facility in the 20 years, 30 years ago, they didn't have such a structured idea. Now the owner operator knows that that this is the data we need. Then that they can communicate with the EPC company beforehand. Then the EPC company is possible. If the owner operator give us the clear the requirement about the information, EPC can do that, right? So in my perspective, the industry is get mature. Even the owner operator knows what is the data needed. Then even during the EPC phases, the owner operator should well communicate with the EPC company, and then the set up the data beforehand. Otherwise, it's never happen. Obviously, in the brownfield is much difficult than greenfield.
Okay. All right. Thank you, Hiroyuki. That's interesting. I think we are more realistic on this one. So when we plan to implement the digital twin, I think we should really consider those kind of challenges, just to ensure that we plan really things very well in advance.
Yep. If I may, I would like to.
Segaf, is there something you want to add?
Yes, I just want to add something on that note. Yeah. So if it's okay, so because I think it's always good to have a digital mindset as early as possible. So digital mindset, you have your digital mindset as early as possible. It's always better. But we also need to understand the challenge on especially in our industry, oil and gas industry. Often the owner operator, they will split their organizations based on this life cycle, right? Engineering life cycles, and then project life cycles, and then they will have another organizations to look after the operation and maintenance. Because this organization is often run in silos, sometimes their objectives also not aligned, right? So when you talk with the project team, their goal is simple: deliver the project on time, on budget, on time, on schedule, right?
Yeah.
Mitigate the risk. but then they never think too much about what they deliver to help the later stage operate on the operation life cycle. So it's never on their mind. So to bridge this, we need, a strong leadership to tell the team, okay, even though these organizations have different objectives, different mindset, we need to think at the end we are working for the same organizations. And when we execute our project, we need to have a digital mindset. When we design our solution at the end, during the handover, we are not only hand over the physical asset, but we are also hand overing the digital twin on the same time. Because I have a very bad experience where I noticed that after 5 years or more than 5 years of operations, the operation team is still struggling to populate their operation system, their enterprise asset management, because everything is handed over in hard copy, and they will have to look at hard copy. So if we can help them, right, during the handover, do not only hand over the physical asset to operate, but also hand over the digital twin. All this information in digital format, so they can populate their enterprise asset management easily. They can populate their inspection system. They can use this for decision support system, improve their reliability, reduce their environment trace. So all these things better if we can have a digital mindset as early as possible. Thank you.
Okay, thank you, Pak Segaf. It seems like you are pointing out the mindset first, yeah. Maybe this is also related to the position why the energy industry is still on the lowest part, because I believe there is something that behind all the reason why it is on the lowest part of the curve on the digital transformation, and I think it will be our challenge. In fact, there are some still other lots of questions in the audience mind that come up with me here and also with myself. But I think the time is really limited, and I need to stop here, and I need to conclude that digital twin. I think we can conclude that the digital twin is really required to manage risk, to reduce cost, and to improve the availability of the facilities for the operation. Why? Because this is to detect, prevent, predict, and optimize through the real analytic and action. And to implement the digital twin or the digital transformation for the oil and gas, especially on operation, the best way is really to start from the project with the mindset shifting first on the requirement of implementing the digital twin. We have had a discussion on implementation of the digital platform on the project previously, and one of the most important thing in the mind shifting is the shifting from the document-centric to the data-centric, transforming from the document to the data, so that we can really work to manage the project, to manage the engineering, and transfer it to operation if we are really managing the data. And again, data is always our big issue. So this is the one that I think we need to attack first, having the mindset on the data, and having the data to be managed. And then after that, really, we will have the digital twin as we expect. So the speakers, thanks a lot for the time and opportunity to present all your experience, your thought. I think those are very Desi. Thank you. See you again next time. And Bu Desi, please.
Thank you.
Thank you very much. Thank you.
Thank you to all the speakers on the second session, as well to Pak Edwin for moderating this session. Ladies and gentlemen, we have now concluded our event. Hopefully now we have a better understanding and knowledge around the potential use of AI and digital twin in our work. Again, I would like to extend my highest appreciation to all the speakers and the moderators for taking the time out of your busy schedule to talk to us. For all the attendees, I would like to request one final favor, which is for you to fill in the feedback form. The link is in the chat as well, as this will help us to continuously improve our next event. You can still access the form outside of this Zoom platform. Just make sure you click the link now and it will open up the internet browser with the feedback form. Lastly, I do hope we can meet again in the next programs. Until then, stay safe and healthy. Wassalamualaikum warahmatullahi wabarakatuh.